Hello and welcome to this seminar on the future of green tech and air quality. My name's Helen Czerski, I'm the host for today, and it's a real pleasure to join you. We've got a really exciting day ahead, lots and lots of talks, lots of different topics, and I'm sure everybody will find lots of things to discuss and to think about and to help us all improve in the future. So basically the way the day is going to work is like this. We'll have pairs of talks, so each speaker will speak for 20 minutes, there'll be one and then another one, and then the time for questions will come after that. So you can hold on to your questions, but you will get a chance to ask them. Now when you want to ask questions, you can put them in the Q&A box, so you'll be able to ask questions throughout the day. I'll tell you a little bit more about that in a minute. So we've got a full day. There will be lunch breaks and tea breaks and all those things to give your brain a bit of a rest. And one important thing to mention is that this whole session will be recorded, so we can share it with as many people as possible. And that means that if you do ask a question, you're basically giving your consent to your question being recorded as well. So do just bear that in mind. Now, of course, it's very important to acknowledge the people who have made all this happen, the organisers, and that is Camden Clean Air, the Camden Clean Air Initiative. And if you've not come across it, if you're here, you've probably heard of them before, but if you haven't, they're a non-profit action group. Their aim is to reduce air pollution across the borough of Camden, and they do loads of stuff that I really do recommend having a look at the website. There's lots of resources there, toolkits on how to help reduce air pollution, and really helping everybody, so businesses, households, schools, helping everyone to get involved. And they've got community projects around things like increasing electric vehicle charging infrastructure and air quality sensors, and this wonderful idea of community parklets, which is great, very tiny parks, which will make a difference. And they organise events like this one, and they've also got a podcast called Racing Green. So do have a look at all of those things, but not this second, because we've got we're going to get started in a minute. One other thing is that if you want to tweet during the day, please do that. We have a hashtag, and it is hashtag the future of green tech. So hashtag the future of green tech, all one long word. So do tweet along or tweet about the event and share this with your networks, because we want everyone to come and listen and learn about what we're going to about these topics. So we've got a real mixture of events today. The first session will be on indoor and outdoor air pollution, and that will be followed by the health impacts of air pollution, and then electrification and carbonisation to start the afternoon, and cities, second session in the afternoon, both in London and Beijing. So there's a very, very broad range of topics, obviously relevant to Camden because they're relevant to everywhere, but also I hope there's lots of you from outside Camden, because we want to share good practice and share good ideas as widely as possible. So I think that, the thing about the questions, while I remember, is that if you have questions as you're going along, the way that the questions will be organised is that you should be able to see a little Q&A box at the bottom of the screen. Now, there are two places that you can type things. One is the Q&A box and one is the chat box. If you put it in the Q&A one, we will treat it as a question. If you put it in a chat, we'll assume you're just chatting with other people in the session as you go along. So it may get bumped into the Q&A thing, but if you want to ask a question of the speakers, please do put it in the Q&A box, not the chat box. And we'd also appreciate it if you make sure that they are questions and not comments. I'm sure your life story is lovely, but we'd like to direct questions to the speakers because we want to hear their expertise on the things you have to ask them. So please do keep the questions relatively short. So I think that is all the getting going bits and pieces. So it is time to get started. And our first session is on indoor and outdoor air pollution, starting with outdoor air pollution. And our first speaker is Matthew Johnson from AirLabs. So Matthew, the floor is yours.
Thank you very much. I'll just share my screen here and we can get going. I think it's a wonderful event and very exciting because we have installed the world's largest network of air quality sensors in Camden. And then I'm able to tell you today about the first results and give you kind of a sneak peek about what we're able to see using this network. And you can see my slides and everything. It looks good. Wonderful.
Yes.
All right. Just a very brief introduction to myself. My name is Matthew Johnson. I'm the Chief Science Officer at AirLabs. I'm also a professor of atmospheric chemistry at the University of Copenhagen. Now, Camden was really at the forefront in taking the initiative to raise awareness about air pollution. And you can see that already in 2008, Camden was adopting the World Health Organization air quality guidelines as a guide for change. And we're going to refer back to these because they were recently revised in order to really recognize the danger that people are being put in due to air quality issues. And I think also Camden, right, rebellious streak, power to create change, and lead by example. And all of these things we will be seeing here today. Of course, why are we talking about air pollution? There's 40,000 premature deaths each year in the United Kingdom. Globally, there's 7 million, maybe 8 million deaths, depending on the method that you use every year due to air pollution. This is more than are being killed, for example, by the coronavirus epidemic, or by all forms of violence combined, including war. And so I think we are interested in the environment, but we can also be interested in air quality for very important reasons. I think it ranks as the world's #1 environmental threat and a serious threat to the public. This is due to these consequences that include cancer, heart disease, strokes, and asthma. And as Helen said, we'll be hearing more about that a little bit later today. And finally, what we're doing is that AirLabs has a partnership with Camden Council and the Camden Clean Air Initiative in order to put up these sensors and learn a little bit about air quality. So we've put up a network, and this has really started to take shape in January and February of this year. And so, really, you guys are the very first people to hear about this. Some features of this network are that we've used low-cost sensors. The idea here is to enhance the existing system of monitoring stations that you have in London. Now, those are really intended to give a good picture of the background urban air pollution, but they do not give you a detailed picture of street level pollution. And that's what we're able to do with the low-cost sensors. We can do that for two reasons. One is that they have a low cost, so you can buy a lot of them. We have over 200 of them just in the borough of Camden. In addition, they're very fast, and so we get updates about the air quality once a minute. And so you have a movie updating very regularly, very high density, that allows you to see the hyper-local variation in air pollution. And why is that important? It's important because, as it is today, Camden is very close to those thresholds that the World Health Organization set out. And so these additional exposures that you have from local sources, maybe street level sources, they tend to be the things that could push you over the edge as in terms of air pollution exposure. So it's important to know what they are, identify them, and try to control them and to reduce your own exposure. And of course, we would like to be at the cutting edge of technology and use these things in order to contribute to the public good. What we'll do with this network is to provide very high spatial resolution, and we're logging all of this data in real time. Finally, we'd like to use this information in order to improve decision-making and awareness of the issues of air quality. Now, why should we be concerned with air quality? Of course, it has some impacts on people. If we just look at particulate matter, your body is built to protect you against exposure to particulate matter. One of our evolutionary traits is that we can tolerate being around a fire, of course, right? And we have a defensive mechanism that your nose should filter out those particles and dust and so on, and the coarse particles. And the problem is that the coarse particles are sticking into the mucus, and that's good, but the fine particles and the ultrafine particles are not sticking. And you know, you produce about a liter, excuse me, a liter of mucus every day. What do you do with it? You swallow it, and it goes into your stomach, and your stomach is very good at neutralizing all of the toxins that might be present in the things that you breathe. You have an acid bath, you have enzymes, anything that you ingest has to be absorbed across a membrane. So there are very many things that protect you against toxins that you might eat. In comparison, if you breathe something and it deposits in your lungs, it goes directly into your bloodstream. And so the toxicity of something that you might breathe could be 1,000 times higher than something that you might ingest. And so we have a special toxicity for these ultrafine particles that are on the smaller end of this scale, this size scale. This includes diesel soot and particles that are made by road dust and brakes and so on. And of course, there are also the chemical pollutants. Nitrogen dioxide and ozone are foremost among those that are just causing oxidation of you and oxidative stress. So altogether, these things cause oxidation of you, they cause an inflammatory response, and this kind of messes up your immune system, and that causes stress. And so you have some stress-related health outcomes, could be heart disease, hypertension. The inflammatory response is also somehow linked with diabetes, and so there's a link between air pollution exposure and diabetes. And in addition, air pollution, cardiopulmonary, there's toxic responses that lead to cancer, right? That's the final group of diseases that you see based on this. But again, more information later today. In response to this, just recently, the World Health Organization slashed their exposure limits for different kinds of key air pollutants. You see that PM 2.5 was reduced from 10 to 5 micrograms per cubic meter, factor of 2 change in what they see as being dangerous. PM 10, that's particles that are a little bit larger, also being reduced. And we have a reduction of a factor of 4 in the amount of NO2 air pollution that is tolerable. And this puts most of London in the zone of exceeding this exposure threshold. This is an annual average air pollution exposure threshold. So now, what have we done? This skipped over a couple of slides. So that point is emphasized by this data from the London Air project. And you can see here that in 2016, they made a map of nitrogen dioxide. It's an annual average map of nitrogen dioxide. And you can see that in this region, it is in exceedance of the exposure limit. That was before the exposure limit was reduced. And this is why we believe that this local variation, for example, the additional exposure you have near a street, is very significant in terms of putting people over the limit. We're also very close to the limits for PM10 and PM 2.5. This is an annual average. We get a lot of additional information by looking at the low-cost sensors. And of course, the main concern you would have with a low-cost sensor is how accurate they are. And so I would like to start by just showing you the calibration of our low-cost sensors. We were very happy to be able to work with Professor Prashant Kumar at the University of Surrey. And we just put 24 sensors at his university outside in the parking lot for 3 weeks. And then we get the intercalibration. And we did this for carbon dioxide sensors, PM 2.5, ozone, and NO2. And we get a very high correlation coefficient for all of these pollutants. And this shows that they are in accordance with indicative measurements. And so this is a standard that you can look up for low-cost sensors. So we have very good performance for these sensors. Another thing that we did was we were able to use a vehicle that's just loaded with very top of the line air pollution monitoring instruments. And then we drove this vehicle around Camden. And in addition, we put some of our sensor nodes into a box on the roof of the car. And so then we could get an intercalibration between the instruments and the live measurements in the top of the car. We have a traceable standard in the calibration of these instruments that are in the car. And then we could do live mapping of the air pollution levels that we have in Camden. Those are the results that I will show you now. And these are the calibration of the sensors in the roof box above that vehicle. And again, very excellent performance. These are some of the maps that we were able to record. And this is nitrogen dioxide. One thing you can notice is the extremely high levels that we were seeing on the roads around London. Over 200 and over 300 micrograms per cubic meter. And of course, for reference, these are the WHO annual exposure limits. But you see a lot of hyperlocal variation. This is variation in both space and time. And that's why we think that this is very important. Now, of course, the monitoring stations that exist right now are doing an excellent job. Their main task in life is to give a picture of the urban background air pollution. And so the time resolution is not very high, and they're often located away from local sources of air pollution. And so we think that this dense network complements the information that you're getting from the existing monitoring network. They have a different purpose. We can use that data to supplement and calibrate what we're getting with our data. But we think both approaches are needed in order to find out what an individual is exposed to in a city. This is another microenvironment. Here we have Limehouse to Canning Town, and again, very high levels of nitrogen dioxide and a lot of local variation in the air pollution levels. Now, here's the maps that we are able to create using the dense network we've deployed in Camden. And so here we're looking at the 25th of February, and at 2 different times of day. We have in the morning and during the day. And so you see the high morning rush hour nitrogen dioxide pollution levels. During the day, that starts to ventilate off and the air pollution levels come down a little bit. And so there's variation according to location, but also according to time. We have carbon dioxide sensors as well. And you would expect to see the background level of carbon dioxide, which is around 410 parts per million. But you can also see a lot of activity in the city. And so here you see on the afternoon of the 25th of February, across Camden, there's very high carbon dioxide levels. And I think that something special must have been happening on that day. And you know, of course, I'm located in Copenhagen, so I don't know what was special in particular about, I don't know if there was a football match going on that day, or maybe, I suppose it was payday, and maybe everybody went outside on Friday afternoon to see this. But apparently there was a wave of carbon dioxide across the city. Now, I saw somebody make a greenhouse gas emission budget for San Francisco using a similar method. And I think that a lot of locations are interested in being carbon neutral. And this is a way that you could use in order to monitor the local emissions of carbon dioxide. Here we have a little of the live data. And so here, this is the 1st of March, going from 6 o'clock to 7 o'clock to 8 o'clock, looking at nitrogen dioxide. Of course, the tube strike was going on the 1st of March. And so a lot of people were driving. And so you can see that the nitrogen dioxide pollution was quickly building up on that day. And then finally, looking at the mobile monitoring vehicle data, and you can see that intersections are often pollution exposure hotspots. There were a lot of people that were involved in this effort. This is the team at AirLabs that was working on this. We're located at 88 Baker Street. And I've been very happy for this collaboration that we've had with the Camden Clean Air Initiative. People may be interested in finding out how they could be involved. And we are looking for sponsors for these air nodes. And so if you would like to host an air node, you're welcome to contact us. And thank you very much for your time and for your attention.
Thank you very much, Matthew. I can see that there are comments and questions starting, and I should have mentioned at the start actually that I was paying a lot of attention to those maps because I'm in Camden at the moment. I'm an academic at University College London. This is what an academic's office looks like. And so, yes, I was paying a lot of attention to where the darker areas were on those maps. Well, we will have questions for you. I'm sure there'll be lots of questions for you when we get to the questions, but we're not going to get there quite yet because first of all, we are going to hear about indoor pollution from Francesca Brady from AirRated. So Francesca, the floor is yours.
Thank you very much. And thank you, Matthew. That was fascinating. So bear with me whilst I share my screen. Here we go. Okie dokie. Here we go. Presume that's working okay. Thanks, Helen.
Yes, that's fine.
Cool, thank you. So yeah, I'm Francesca Brady, CEO at AirRated. What we do is basically make the invisible visible. So we look purely at indoor air quality and we aim to assess the performance in a building and then classify it. So it's nice and easy to digest by end users, so people in the building and key stakeholders. But what I'll be talking to you about today is indoor air pollution. Quite a nice follow-on from Matthew and outdoor air pollution. So in actual fact, I'm going to start there. So these masks probably look familiar, but it's not to do with the dreaded you-know-what. This was actually the Great Smog of London in 1952. And it was the worst air pollution the UK has, or the worst air pollution event the UK has ever seen. But it was also the most significant in its effect on environmental research, government regulation and public awareness, and the link between air quality and health. So after this event in 1952, there were changes to practice and regulation, drastic to begin with, and the most notable perhaps being the introduction of the Clean Air Act 4 years later in 1956. So I'll go on to the next slide. Outdoor air pollution has always been a hot topic of interest. There's been a great deal of media coverage, a great deal of research around outdoor air quality, outdoor air pollution, its sources, its impacts. As you can see here, climate change and air pollution among the top threats to global health. So along with changing physical climates, we're also looking at the change in health and the impact on ourselves. There was also a really tragic case, Ella, a 9-year-old girl who died as a result of outdoor air quality. So there's been a huge amount of focus, a huge amount of awareness generated around this topic. It's hugely significant and seems to have not really been taken with the seriousness and importance it should do until now. So since COVID, we've also seen topics in mainstream media like how clean is the air in your office? And I think a lot of people probably looked at that title and thought, I have no idea. Likewise, with outdoor air quality, there is a degree of visibility, but particularly when we look to indoor environments, it's hugely lacking at the moment. So great deal of awareness through media coverage. And we actually commissioned a survey. So we went out to hundreds of people and asked them about their awareness around the topic of indoor air quality. Now that we know that it's starting to infiltrate mainstream media, how is it changing people's behaviors and people's attitudes towards indoor air quality? So when we first did the study, it was back in 2020, and specifically in the UK, people's awareness, I mean, how did your level of awareness increase in the last year? 57% in 2020. In 2021, this leapt up by 20% to 77%. So it's one of those things that education and awareness is growing, and that is being impacted, and we can see that through data that we are starting to collect. Has COVID made you more concerned about air quality? I think the reason that it's, yes, significantly more concerned by most people is the fact that the WHO recognized that COVID was airborne, and therefore people, particularly in buildings, were linking COVID and the transmission of COVID and how likely they were to contract COVID with air quality. As a result of that, they've become more concerned. The really interesting part, and the last data point on this slide that I'll touch on, is if a company wasn't transparent about the quality of their indoor air, would it influence your decision to work with them? So not only is it having an impact on how we as individuals perceive our health and our well-being, both outdoors and indoors, but also whether or not we would work for a business. So it's the business impact as well. And I think that's hugely important, because sometimes, you know, air quality, anything related to health can feel quite distinct and quite personal, and doesn't necessarily transition into anything financial or anything quantifiable when it comes to businesses. But in this case, it does. So just moving swiftly across, Matthew and I didn't work on our slides together, but I did include it online. This is just about awareness still, so, and the accessibility of data, allowing our awareness and education to grow. So companies like AirLabs, who are deploying this large sensor network over Camden, will eventually have their data publicly accessible. At the moment, we've got sites like Tomorrow.io and Breezometer, where you can Google them and you can type in your home address or your work address, and you can look at the external pollution in the area that you live or work. And I don't think it's a massive assumption to make that people would start to base life decisions around the quality of the air outside. Likewise, I've put some pictures up on screen on the right-hand side, terrible with left and right, of a little dongle. So the little black dongle is called Plume Labs. It's something that is called a personal exposure monitor. So you can hook it onto your handbag, your briefcase, walk around London with it, say, and track your personal exposure to air pollution. The other two devices, so the small circular one and the one just above it, the small circular one is a commercial grade sensor. So the sensors that we are starting to see more and more of in the indoor setting, so in commercial offices, for example. The one above it is one that IKEA have recently released, and it only tracks dust, so PM10 at the moment. But it's one of those things that, because it is in the forefront of everyone's minds, even the likes of IKEA are starting to recognize that, and they're starting to create consumer products that are tailored towards people wanting more control over their spaces, but also more control, more visibility over the health of their spaces. So these are two examples of where the accessibility and the price point of things like indoor air quality monitors and technology have started to filter into policy and regulation. So you may have heard of the UK rollout of carbon dioxide sensors to go into schools. So this is because carbon dioxide, so CO2, is a really good indicator of occupant density, how many people you've got in a space, and ventilation effectiveness, two of which are key risk factors for transmission of COVID. So in the indoor environment, this is a really low cost, easy way to just start to identify some areas where you perhaps have more risk of things that might cause a transmission of a virus. Likewise, the Part F building regulations has been updated recently, and there will be a mandatory requirement to include CO2 sensors that are mains powered into new buildings and heavy refurbishments. Both of these things are a knee-jerk reaction of COVID, but they are definitely a step in the right direction. When we look at the quality of the indoor air, carbon dioxide isn't necessarily the best indicator to be using, but like I said, it's a good start. So when it comes to what is a good starting point, perhaps beyond CO2, because in my humble personal opinion, we could have done more at this point, I'm just going to run through some parameters that we could be measuring in our schools, in our offices, that are, again, really, really easily accessible and really easy to monitor, and are found in a lot of the commercial grade monitors on the market. To Matthew's point, there is a buyer's beware point to be made about commercial grade sensors. Some of them are relatively good, and some of them have been studied and evaluated by academic bodies. Some of them are not so good, just a word of warning to everyone. But I'm just going to run through some parameters that are nice and easy to relate to, but also are monitored by a fair few of these devices. So the first is PM 2.5, so particulate matter with a diameter of 2.5 microns or less. Doesn't really mean anything to anyone, but it's around 3% of the width of a human hair. So it's really fine particles. I know Matthew's touched on this, but they can get really deep into the lungs. And then you have your ultrafine particles, so even smaller than that, that are so small they can even get into the bloodstream in some cases. Things like particulate matter can aggravate conditions such as asthma. So I mean, particularly where you've got a vulnerable group of people, perhaps suffer from COPD, asthma, maybe they're recovering from COVID and their lung health isn't perhaps as good as it was before. This is the sort of stuff that's going to aggravate those sorts of conditions. So really nasty stuff. We should be trying to keep those levels as low as possible. In buildings, we've got, particularly in offices, we've got big units on the roofs of our buildings that have filters on them. They filter out a lot of the coarser material. Sometimes that fine stuff can make its way into our environments, which is why we do see a really strong trend with outdoor levels of this fine dust and indoor levels. So we know it has an impact on our health, but actually, I guess the lesser known fact is that it has an impact on our productivity. So I just put this slide up because it was a really interesting study on investor behavior. So the study was conducted on the S&P 500, and it saw that with one standard deviation increase of PM 2.5 in the ambient air, the same day returns dropped by 11.9%. So I know that particularly today, we all care about the health impact, but I think it's always important to try and draw it back also to the quantitative kind of financial benefit of doing these things, because at the end of the day, if we want to make these improvements, if we want to start monitoring our air, there needs to be that sense of return on investment. People need to know that they're getting something back for their money. It's just the cold, hard truth of it, particularly when we're looking at commercial offices. Carbon dioxide. So it's the one that I've mentioned previously in terms of CO2 monitors being rolled out in schools. Really good proxy for understanding how many people you have in a space and perhaps ventilation effectiveness. The levels that we see in our indoor environments, so our homes and our offices and perhaps our schools, aren't necessarily going to reach levels that would be deemed unsafe. So what we look at really in terms of CO2 is how does it affect our comfort? Because sometimes when you have elevated levels above 1,000 parts per million, you start to feel a little groggy. It feels a bit stuffy in the room. You start to feel a bit headachy. But also it impacts, bringing it back again to productivity, it can impact cognitive performance. So how your brain processes data, how you make decisions, and that sort of thing. And there was a really kind of interesting, quirky, not sure how scientific it is, stat about how when you reach 1,000 parts per million of CO2, your cognitive performance is impacted the same as having 2 pints of beer. Again, not sure how scientific that is, but it's quite a nice stat and something to just make this quite complex topic slightly more relatable to people. Okay, ironically, I'm going to make it less relatable. This is a graph little aggressive with the colors, that shows the impact in certain areas of our cognitive performance from basic activity through to, information usage, and how it's impacted by different levels of CO2. So you'll see at the top, the white circle is 600 parts per million. So that would be the absolute ideal working environment. 1,000 is what we would probably class as a typical office environment. 2,500 is probably more representative of a meeting room, midway through towards the end of a meeting. Hopefully you wouldn't see that so much in an open plan environment. But as you can see here, particularly when you start to reach these levels in exceedance of 2,000, a lot of the factors that we're looking at, basic activity, drops off a cliff. So all these sorts of things that if you're searching information, not necessarily impacted, but if you're trying to use that information, it will be impacted. So just some sort of nice facts there. Tvocs, so this parameter is a bit of a nightmare in the academic world, but I'll still talk about it anyway. So Tvocs are total volatile organic compounds, basically things you can smell, chemicals. Kind of some of the common sources of Tvocs are new furniture and soft furnishings. So, new sofa that you might have, new car smell is sometimes a good way to relate to VOCs, but also paints and finishes. If you're in an existing building, the sources might be more in line with cleaning products. So if you're in a commercial office, cleaning activity will promote the off-gassing release of Tvocs. So Tvocs are sometimes not very harmful at all. So it can be the organic gases that are emitted from your lunch. In other cases, they can be more harmful. So formaldehyde, that's sometimes a byproduct of MDF. Some cleaning products that are quite potent can be irritants for eyes and your skin. So sometimes not nice, sometimes okay, really difficult to tell with the broad term, but also it's quite good indication along with CO2 for ventilation effectiveness. So I thought I'd use this graph because sometimes it is, widely acknowledged that it's a good thing to switch from potent cleaning chemicals to more eco-friendly low VOC ones. But this is just to show the significance of swapping. So you still see a rise. So the potent cleaning chemical is the one with the orange dot. So you see a really high rise in VOCs, and it tails off to a degree, but quite slowly over time. With the eco product, the low VOC one, there's a much smaller rise when you're using it. Again, it tails off slowly, but much smaller to begin with. So much better for not only the environment, but for health if you switch to these sorts of products. Temperature. So this is the most commonly cited complaint, particularly in an office. Temperature can have an impact on health and well-being. So if you've got consistently high temperatures, consistently low temperatures, or big fluctuations in temperature, that can impact your health, but also your comfort. It's one of the factors that contributes to something called sick building syndrome, where you feel a bit headachy and a bit like you've got a cold. But as soon as you leave the indoor environment, those symptoms are sort of alleviated. So that term was coined a couple of decades ago, but temperature is one of the factors that plays into that. Temperature can also have an impact on productivity, the common theme of today. So when it comes to productivity, it's a general rule of thumb that for every degree above 25 degrees Celsius, you lose about 2% in productivity. Completely understand that both with temperature and also productivity, there are so many other factors that come into play, but just if you were looking at it in a controlled environment with a controlled study, that's the general rule of thumb. This is just a really ugly graph to show you what I've just told you, but the kind of optimum temperature is 21 to 22 degrees Celsius. And then you can see either side of that starts to drop off for productivity. Humidity. So I know Matthew's already talked about mucous membranes, so you'll be thrilled that I'm about to talk about them as well. With humidity, the absolute ideal range that you would have is 40 to 60% humidity, relative humidity in the indoor environment. tends to be in the UK, because we have a temperate climate, that we pull really cold outdoor air into our buildings in winter, and then we heat it up. And in the process of heating it up, strips the moisture out of the air. So activities that would contribute to adding moisture to the air are things like cooking and cleaning and bathing. In an office environment, you're perhaps not doing that so much. So it means that those environments in particular get a lot drier, because there's not a lot of activity to add humidity back to the air other than people breathing in the space. So in those sorts of environments, it's been a really key area that we need to focus on when it comes to how do we adapt our buildings and optimize them to make sure they're healthy spaces that can help us in this fight with viruses like COVID, like the common cold and flu. So if you've got drier environments, it promotes the survival rate of some viruses. It allows some of them to travel further than they would ordinarily in an environment with higher humidity. But also lower humidity dries out your mucous membranes, and that is your body's natural defense to picking up these sorts of viruses. So one really key thing, and probably the unsung hero of a healthy building. This again is just a nice graph to show you that optimal range, and then as you fall either side of it, you have higher infectivity of pathogens, you have slightly less productivity, and you have slightly poorer sleep quality, and that sort of thing. So 40-60, absolute optimal. So it's not all bad news. I know we've talked about death and mucus a lot, but since 1997, the deaths or premature deaths attributed to indoor air pollution have dropped by 33%. So between 1997 and 2017. And that is because we started to become mindful, and we started to gather data and knowledge around using things like asbestos in our environments. It wasn't good for us, but it took us time to figure that out. And now we've completely got a blanket ban on those sorts of things. Again, with paints, we were using paints with lead in them. We were using high VOC paints. After time, the more that we could gather data, the more that it became visible to us that this was having an impact on our health in our internal environments. We started to put rules and regulations about how the content of VOCs in our paints. So that's me done. Thank you so much. If you want to ask any questions, I can see 13 in the Q&A. So hoping Matthew and I have lots to talk about.
Thank you very much, Francesca, and especially thank you for running through some of the types of air pollution. I think one of the great difficulties in this debate is that people see air pollution as one thing, and it isn't. It's lots of different things that come from lots of different places and go away in lots of different ways, and they're often quite technical terms, so it's very much appreciate you running through some of those. Okay, we do have now 20 to 25 minutes for questions. The way this is going to work is that if I will look at the questions in the Q&A thing, so if your question is not in the Q&A thing, or someone doesn't put it there for me, I'm probably not going to spot it. So I will pick out questions. I will tell you which question it is, and that the magic of behind the scenes will unmute that person, and they'll be able to ask their question out loud. So that's the only time you get to be unmuted. And please keep your question short in that case. And then if nobody pipes up at that point, I'll assume that they've gone to the loo or something, and I will read out their question. But I'm actually going to take the privilege of asking the first question for Matthew, just because I think this is a very important point to cover straight away. And Matthew, my question is, how are you conveying, or, you know, well, I'm interested in the importance of transport versus local generation. So a pollution spike that you measure could be from the building next door, or it could actually have happened 50 miles away and it's kind of blown over London. And so how do we know which is which, basically, and help people interpret that data?
It's a super good question, and we could talk all day. But the basic thing to think about is that some of the air pollution, you know, on a nice summer day, it turns out that ozone air pollution levels could be really high. And so you might have a cloud of air coming from, I don't know, Poland or Germany or something that drifts up over the UK. And then that means that the ozone concentration is just kind of going up and then going down very slowly, and that it's a regional air pollutant. And so or for example, sometimes we get a lot of particle air pollution from Sahara dust, and you just get a dust episode and it comes all the way up here and then slowly up and slowly down, and all the sensors are showing the same thing. Now, in addition to that regional air pollution, you have some kind of just general air pollution from London. So it's like the urban background air pollution. But in addition to that, you have the very local sources. And maybe that's a heavy truck with a poorly tuned engine, or a barbecue restaurant. So one tool you can use is simply to look at the time response of the sensors. And is it slowly going up and slowly going down? Then it's a regional pollutant. If it's a very sharp peak, you know it's a local peak. And maybe it's only one of your sensors that's showing it. And then you know also from the location of the sensor and the wind direction where it's coming from. So those kinds of hints can answer the question. But the other thing is that different kinds of pollution have a different composition. And so if it is home heating, maybe people think it's cozy to burn, I don't know, wood or peat or coal or something. That has a very different profile of particles and soot and so on as the transportation source. And maybe transportation has a rush hour in the morning and in the afternoon, and home heating might have a very different thing. So we use a number of tools to differentiate these sources and try to figure out what is the best control strategy, and what percentage is local, what percentage is regional. We find that perhaps about 2/3 of the nitrogen dioxide is local, whereas something like ozone, most of it is regional or international. So it wouldn't make sense for Camden to have its own strategy for ozone air pollution, for example. But for NO2, I think there you could have an impact.
Great, thank you. And one thing I should have said actually for the audience is that we do have a lot of questions in the list. Don't be afraid to ask more, because if there are more questions than we can answer now, we will get those questions to the speakers afterwards. So please don't be put off. If you've got a question, please put it in the Q&A. Okay, so I would like to ask, well, let's pick one from the top here. So Ohad Jivan, would you like to, when you're unmuted, would you like to ask your question, please? Yes, go ahead. I'm not sure if you're speaking, but I can't hear you.
Okay, now can you hear me?
Yes.
Perfect. Mute, silly button. Okay, so a small question for Matthew. I saw that you calibrated for 3 weeks, right? The sensors. I was wondering how will you correct or how will you address seasonal variation? Because it's a big thing for those sensors. They're extremely affected by temperature and relative humidity and anything else related. So
definitely, yeah. We would just spend all our time calibrating if we could, because it's so important and it's so much fun. But you're exactly right. And so we get all of the data, and then we're checking that all the time. And there's a number of things that you can do with cloud calibration. So we pre-calibrate before we deploy them in the field. But then, as you say, the sensors can drift over time, and they're also going to respond to seasonal changes differently. So one of the methods you can use is just to look for an individual sensor and see, is it going crazy? Because a spider got into your node and laid an egg on the sensor, or maybe it's leaking electrolyte, or there's 100 things that could happen. So that's one way. But another way is that you can use this regional air pollution signal, which ought to be the same for all of the sensors in the network. And then that will tell you if there's any deviation, especially in a quiet period when you don't have the local air pollution. Like 2 o'clock in the morning, you would expect everything to pretty much be the same. And it's not perfect, but it'll give you a pretty good idea that that you're on the right track.
Great, thank you, Matthew. Okay, so the next question will be from Mark Nichols, who has a question for Francesca. So Mark, if you'd like to, when you're unmuted, ask your question, please.
Sure, can you hear me?
Yes.
Awesome. Yeah, my question, Francesca, how are you doing? I've heard anecdotal evidence that some species of indoor houseplants can actually emit VOCs as well. I just wondered if you had any thoughts on this. So I'm not sure what my opinion is.
So anecdotal evidence, I mean, I have seen there's quite a commonly used NASA study to talk about the positive impact on air pollution and the fact that peace lilies are quite good for that. The kind of, so I mean, anecdotally, I've got a plant right behind me. Saw this one the other day. There was just a layer of, it looked like white fluff on the soil. And there was a really thin layer of dust on the leaves. So sometimes with plants, they can be great at lowering, not significantly, but marginally, lowering levels of VOCs and CO2 in the indoor environment. But you would need a huge number of them to generate a significant impact. The one thing that can end up happening sometimes with plants is that they do gather dust on, particularly if they've got big leaves, can gather dust on them. So if you were to walk past it or brush it, then it can resuspend those particles, and that doesn't necessarily lead to having better air quality. And also with the kind of build-up of moisture, and if you've got quite a warm, damp environment, sometimes you can get kind of low levels of mold that grow on the soil. That can release VOCs. So anecdotally, I love them because I like the concept of biophilia and our innate desire to connect with nature. Sometimes air quality wise, it is not the silver bullet that I think everyone kind of hoped it would be. So that's my anecdotal evidence. I do love them, but not necessarily for improving air quality that well. So perhaps don't turn all your offices and living rooms into tropical greenhouses. Is what we're hearing there. Okay, so next up, Kristen Tapping has a question for Matthew. Kristen, would you like to speak when you're unmuted, please? Oh, taking a little while to...
I think Christian has left.
Oh, okay, well, I will ask the question in that case. So the question, which other people might be interested in the answer, so we'll ask it anyway, is how about filtering NOx, which are nitrogen oxides? Can you filter it out if you know it's there? And could AirLabs, conduct such tests?
Definitely.
Oh, by the way, Helen, I'm unmuted now, so I'm here. Thank you.
Oh, okay. Well, Matthew is about to answer your question.
Yep. Really excellent question. I haven't told you about the other side of AirLabs business, which is making air filters. And I just happen to have one of our products here. This is called the Air Bubble. And this is made to reduce air pollution inside of vehicles. So it sits behind the headrest, and then you have clean air coming out here. And we've built this specifically for traffic air pollution. And part of that is fine particles, diesel soot that you might be getting, or road dust. But the other part of it is nitrogen dioxide. And it is an issue that not all filters are capturing nitrogen dioxide. Certainly not the usual filter that you have inside of a vehicle. So most vehicles have a pollen filter, and previous work has shown that it's not very good at trapping fine and ultrafine, especially ultrafine air pollution. But those filters are only particle filters. They're not gas filters at all. You can buy some specialist high-end aftermarket filters that would have that additional property. And I think some car manufacturers, very high-end vehicles have started to incorporate that. But you do need special materials. If it's an adsorption filter, sometimes activated charcoal is used for this. And the standard activated charcoal does not have a especially high affinity for NO2, but there are different surface treatments that you can do in order to enhance the affinity for NO2. For example, the surface treatment that we have in the gas filter that goes into the air bubble. Yeah, so there are approaches to get around this.
I would think that filtering an entire atmosphere is quite a large task. So, yes.
Certainly. I heard a statistic once that all of the atmosphere goes through a leaf once per year. And I haven't been able to find the reference for it, but I think it's we're talking about plants, and it's, they're the lungs of the planet.
The atmosphere is quite well mixed, but I'm not sure about that stat, but somebody will know. Okay, so we have a question for Francesca from John Rainford about energy efficiency. John, would you like to ask your question when you're unmuted?
Hello, hi. Yeah, I was just wondering, Francesca, if there's something simple that we can do at home, or not necessarily simple, to improve domestic air quality rather than just opening the doors and windows and letting all the heat out.
I think this is specifically for the homes and also for classrooms, because that's another place where we keep talking about improving the ventilation, and all classrooms have doors and windows. And you're right, it does hugely compromise energy bills, and particularly at the moment, that's a hot topic. So it depends what sort of design features you have. So if you've got trickle ventilation, that is sort of in line with opening doors and windows, but those are sorts of things that you can open the slats for overnight. So when the outdoor pollution is low, nice and low, then it can regulate humidity, it can dilute the buildup of pollutants indoors overnight. That's quite a nice, easy way to do things. I, anecdotally again, don't have that. But there are systems like positive input ventilation that you can put in attic spaces. And that uses pressure differential to force more air around the space, improve airflow, and dilute the buildup of pollutants. If you want to get to the slightly pricier end of things, there are MVHR units. So lots of things that, particularly with PIV, that is very low in terms of its demand on energy usage. Kind of a great thing that is cost effective to put into a home or a naturally ventilated space, but particularly the home environment, because you do sometimes have that attic space available. So I hope that helps.
Right, thank you.
Brilliant, thank you very much. So we have, who asked that question? Where was it? Oh, that's right, it's an anonymous attendee, so I'm going to ask it for Matthew. And it's about whether you're planning to expand this network outside of Camden. And actually, I would add to that, how can people get access to the results themselves? Are they publicly available anywhere?
Yeah, I think we're getting ready for the beta launch of AirScape. And so I posted some of the screenshots from this software. So please just get in touch with us, and we would be happy to have people who would like to help test that software. And definitely, we would like to expand. We're talking with a number of other boroughs about also doing installations in other areas of London, and with a number of corporate sponsors who might be interested in. So we're very happy to receive all inquiries.
Great, thank you. This is a question, I assume this is for Francesca, from Nathan Wood. Nathan, would you like to ask your question when unmuted?
Yeah, hi, thank you. Francesca, bit of a leading question here. Who are the best people to call in for indoor air quality inspections or ventilation checks? Because if you get your boiler service, they need to be gas safe approved. Is there a certificate or IAQ qualification that we should be checking when calling people in? Thank you.
Yeah, really good question. I think particularly when it comes to calling professionals in or trying to deem whether they are professionals, same can go for sensors, is that there's no one kind of widely associated body that people know about that they can go to cross-reference people's qualifications. I'd say that somewhere third party like the Building Engineering Services Association would be a great place. They've got lots of training courses, and just because of the independent nature, it means that people who have gone through the course have the seal of approval from an independent body. And that is probably the check that you have, because with gas safety, there is a very obvious kite mark to look for when it comes to professionals coming into your space. Kind of less known and less understood when it comes to indoor air quality, but big bodies that are associated with ventilation and hygiene are sort of the best places to look.
I think this is a really difficult issue because, and I suspect Matthew might think the same, that I've looked in a basic way at a lot of these air quality sensors, and as someone who measures air quality in the environment, you know, as part of my job studying the natural environment, it is hard. This is a hard thing to do. And these little sensors that say they will deliver the world for 10 pence, you know, I will go a bit further than Francesca and say there's a lot of junk out there. And it is really difficult. Like if you are a consumer and you want to do the right thing, you want to monitor something in your workplace, you know, the world has not delivered a solution for that yet. And it really needs to, you know, sort it out. Okay, so we have a question here from Chetus Rana. I'm sorry, I'm not sure how to pronounce your name. Would you like to ask your question when you're unmuted, please? I'm not sure. We can't hear you. Are you speaking? Oh, maybe the audio is not cooperating here. Well, I will ask the question. And it is about whether there are basically cross-sensitivity effects. So can the sensors differentiate between particles and volatile organic compounds and nitrogen oxides? Can, you know, do the measurements interfere with each other? I guess that's the question.
Yeah, another really good question. And the usual thing you hear is that you can have a sensor that is sensitive, but it's difficult to also get one that is selective. And one example would be nitrogen dioxide and ozone are both oxidizing gases. And so you often have crosstalk between them, that a sensor that senses NO2 would also sense ozone. And so what we've done is to have both sensors, NO2 and ozone, in the same node, and then you're able to correct for that cross sensitivity in that measurement. Now we're not measuring any kind of VOC in these nodes, and as the other presenters have been saying, that there's, you know, hundreds or thousands of these compounds. So I think that would be very challenging to be able to do. And so you can get these cheap little devices, and honestly, I don't really know what they're measuring, these ones that claim to measure VOC, but they kind of indicate high and low. That seems fine. I think that a first step that could be useful is just to have a CO2 sensor. And I think that it gives you a good indication of the balance between the number of people that you have in the space, we're producing CO2, and the ventilation rate that you have in the space. And it can kind of give you an indication whether there might be a problem with adequate ventilation.
Well, I'm going to pick up on that actually to ask Francesca a question, because I think that, and perhaps for you as well, Matthew, but I think that one of the difficulties is that carbon dioxide is, it's present in lots of different contexts. We know if we put carbon dioxide into the atmosphere from burning fossil fuels, that is a bad thing. That's causing climate change. We definitely don't want that. But then when we come to ventilation on the indoors, it's not actually the carbon dioxide, it's just a proxy for ventilation. So the question perhaps for you, Francesca, is in an indoors environment, is too much carbon dioxide harmful to human health apart from making you a bit groggy? Or is it just that it's a proxy for, it's a way of measuring general ventilation, which is relevant for other pollutants?
Yeah, I think it's a really good question. So, I mean, particularly at the moment, because we are so cognizant of the fact that if you are in closer proximity to people who have a virus, COVID or otherwise, you are more likely to contract it. So if you had CO2 as a proxy for how many people were in a space, then you would start to understand the risk indicator or the risk index. When it comes to ventilation, we know that if a space isn't particularly well ventilated, then risk increases. So it's all these things about it. CO2 is a great measure for understanding the indirect impact on health, potential indirect impact on health. When it comes to CO2's direct impact on our health, it's only really where you see levels that are above sort of the health and safety executive 5,000 ppm 8-hour average mark that you would deem it unsafe. So it's kind of coming back to the piece around comfort. And if you're exposed to levels that are, say, 1,500, 2,000, you'll probably feel a bit headachy. So whether you class that as health or comfort is probably by the by. It's impacting you in a negative way, but not necessarily unsafe or unhealthy. Kind of depends on what your definition is of health or safety. But yeah, I'd say it's a great indicator for indirect health impacts, but also comfort. And then, yeah.
And surprisingly variable. Oh, go on, Matthew.
Oh, just to add that the professional working environment is also affected by carbon dioxide, because I put a CO2 sensor into our physical chemistry lecture room, and we came over 2,500 ppm of carbon dioxide during that lecture. And so when the students fall asleep, it's not because of the lecturer, right?
Great excuse.
I'm glad you have scientific data on this topic. I'd certainly know the people who had good quality. I had friends who were taking scientific, research grade CO2 monitors, carbon dioxide monitors around during COVID, and finding that they were very surprised by where was ventilated and where wasn't. It's not always intuitive. And then there was someone who came into a talk, they were a panel member on an event I was hosting, and they brought their air pollution monitor into the theatre. And the quality was terrible. And it turned out there was a diesel truck just outside the air intake for the whole theatre. And he was sitting on stage going, I've never seen numbers like this. Okay, we probably have time for one or two more questions. So Ben, Paul, you've got a question here about monitoring. Would you like to ask your question, please, when you're unmuted? Ben, are you, I'm not sure if you've got a little, your microphone.
Can you hear me?
Off. There you go. Yes, I can now.
Oh, great. Thanks very much. Really interesting stuff. My question is to do with monitoring versus sort of taking action, I suppose. We already know that air pollution is a serious issue for climate and health. And so to what extent should we be focusing our attention on further monitoring versus tackling the sources of air pollution?
I think it's a complicated question, and there's many uses for the data, and it really ranges from people who would be worried about their personal air pollution exposure to people who might be setting, the Mayor of London, of course, is very interested in air quality, and Camden is very interested in air quality, but the European Union is, and the World Health Organization is, and then each of these has their own interests and uses for the data, and so you might think, we know Los Angeles is polluted and Athens is polluted, and Copenhagen, it's not so bad because it's windy and there's not so many people there, right? We know everything that we need to know, but I think that when we can use the low-cost sensors, you get a lot of detailed information that can inform local actions. And they might be actions by individuals. They decide to take a green route to work because they're aware that the road is polluted. Or there's a lot of debate about a low emission zone, or replacing diesel taxis with low emission vehicles. And so maybe you'd like to know how much of the existing air pollution is coming from those sources, and what would be the benefit of changing the transportation fleet. And then there's people, you know, Kings and Imperial and a lot of other places that are really looking at the economics of these decisions. And you can put a price on emissions of nitrogen dioxide or particulate matter. And then really,
I'm gonna, unless you've got one last very quick roundup point.
No,
okay.
just that the data is fascinating. That's my
okay.
point.
General scientist answers for everything. That. So we are running into the tea break ever so slightly, so we're going to stop there. There are a few more questions. We will get those to the speakers, especially the ones about the source of data. That is very important. I'm sure Francesca will be happy to answer those. Now we have a 10-minute tea break, but at 11:20 we will be back, and to hear about more about the specific health effects, and particularly you heard Francesca mention Adoo-Kissi-Debrah, who died from the consequences of air pollution. Her mother will be talking to us. So I think lots of reasons to come back after the tea break. So we'll pause now, back at 11:20, go and get a cup of tea and come back. Hello and welcome back after the tea break. Now, I find myself in an unusual position here because we have two excellent speakers. I thought that Hayley was going first, and as a result of the question I just heard, I'm not sure anymore. So, Rosamund, have you both agreed that Rosamund is going first? I'm sorry not to be entirely sure.
The information which I got, it said, I'm reading it, it said I'm talking between 11:20 and 11:40, that's all. Okay, well, you can go first. That is absolutely fine. I'm sorry for the confusion, and it's the audience is getting to see behind the scenes here. Well, thank you very, very much for joining us today. We really welcome the opportunity to hear about what you're doing at with the Ella Roberta Family Foundation. We all wish you weren't here in a way, but we're very grateful that you are. So first, to get us started, so we'll do this for the audience benefit, we'll do this in a more conversational way. Okay. Rosamund, to get us started, tell us a little bit about the work you're doing with the Ella Roberta Family Foundation.
I think part of the work I'm doing, so before my career really started in research, and part of the work I'm going to be doing is I'm going to do quite a lot of writing, research papers and stuff on Ella's case. So I've got that in the pipeline coming up, something in the Lancet, and writing with various other writers as well. So going back to my first love, which is research, because I want to talk about exposure to air pollution, which I think everybody is actually missing. I've been watching since the inquest came out, and I still don't think the severity of it, people sort of really get it. Tuesday was actually 9 years to the day Ella was buried, actually, which is, I have now lived longer without her than with her, which is quite traumatic in itself. I actually didn't realize that when these anniversaries come around. But I think, you know, people forget to mention simple facts, things like Ella had one of the worst cases of asthma ever recorded in this country. But the area I'd like to really focus on in my research is talking about short-term exposure and long-term exposure. And I also think the point that the coroner made seems to be quite lost on some people when they mention Ella's case, to my dismay. The reason why she actually died was due to where she lived. Now, that is incredibly important. And if you live near a busy road in London, a very busy road, it's similar to passive smoking 15 to 20 cigarettes a day. And I think that seems to be quite lost on people. So I was talking to my children about it, and they were sort of saying, well, Mum, you kind of sort of did this before we were born, really. So I'm going to be going forward, working collaboratively with some researchers and actually get, and also there's only parts of her case that were publicized from the coroner's report. We have all the information from the experts who recommended ULAs and road pricing, and I think I need to bring all those things to the public's attention. Also, one of the things I'm passionate about, and anyone who follows me, is about art. And I believe this particular topic, there are different ways you can get to different audiences. Right now, I don't know whether you know, maybe this is a plug for my borough, that despite all this, I'm proud of, you know, where I live in Lewisham. It's the borough of culture. And I'm very passionate about using art, you know, art, poetry. It's how to get, you know, the coroner was very, very clear about this. So amongst experts, it's all very technical, and amongst environmentalists, but the ordinary person on the road, there is, you know, on the street, there is still so much more that needs to be done. And I've thought very hard about this. You know, it is okay when I go to university, sort of PowerPoints, giving lectures, so that's a specific audience. Environmentalists know about it, but I'm talking at the grassroots level, and I'm trying to find different ways to communicate with them, to let them know the seriousness of the problem. And also, through my journey, I am a bit obsessed about research. I do admit that. I read so many things, and I've realized that lung disease is the poor man's disease, and the communities out there that are most impacted, you would never hear, they just never get the platform. They never get a say. And I always think, I will be doing them an injustice. You know, I still live where I live. I walk down the streets. I know what people are concerned about. And I feel like I need to amplify those voices. I mean, in the future, where I can, I am going to try and get ordinary people who are impacted by air pollution. And the other thing as well is the monitoring and things. I've been looking around. They make it so complicated. I'm thinking, when you got these government websites like DEFRA, you sort of need to know what you are, you know, how many people have got time to do those things. So again, a bit like the coroner says, it's about getting the information out to the ordinary person. This ultimately, I think, is about behavior change. And I sort of, there is an equivalent with the whole smoking. Remember years ago, the whole smoking campaign. And that's why I'm incredibly passionate about working with everyone from health. And I don't know whether you know, but recently we had a health summit. So people are now coming on board. And I think the GPs, respiratory consultants, everybody needs to take part in this. You know, we do have a ticking time bomb. And I just tweeted something. When I read about studies to do with climate, they sort of make it sound as if it is in the future that this catastrophe is going to happen, whereas it is happening now. And I justified it by saying that according to WHO, 7 million people are dying, and they're you know, between 7 and 9 million people are dying prematurely now. And I get very worried about the framing of these things. I sometimes think, who is controlling this whole narrative? Because people are being impacted now. And one of the things I was asked to talk about is health. And what I mean by that is, it is linked to cancers, dementia, you sort of see what's happening, stillbirths, miscarriages, and even COVID. And there, you know, I'm not going to preempt that there is going to be some research to do with COVID and air pollution. So people talk about this, and I get a bit puzzled when, you know, they say, oh, there's 10 years to come or 9 years to come. And I'm thinking, well, not really. Ella died in 2013. Since she died, the number of children that die from asthma has not gone down. Smoking's gone down. So, you know, we can't blame everything on that. And yeah, I think people talk about the future and they're not concentrating on the here and now. And due to the pandemic, I think about 100,000 people are waiting to be diagnosed because they postpone spirometries, but that's like 100,000 people. And we talk about cancer all the time, but like I'm not saying we shouldn't, but lung disease, you know, the poor man's disease, we just don't talk about it. And I do think the health impacts are not stated enough. This is a way to get ordinary people on board. And talking to Frank Kelly from Imperial, my point to him was the data's brilliant, but we do need to find a way of making the invisible visible. And also, I find there's a lot of onus on individuals. I'm not saying individuals shouldn't do their thing, but what I'm really interested in is what is the government doing? What is the mayor doing? And mayor of all cities, by the way, not just London. We know what Mayor Khan is doing. And also for policymakers and who come up with some of these schemes, and some of them have been quite disappointing. And I've always said, by the way, Helen, that personally, I cannot support anything that creates more air pollution. And the reason why I want to talk about exposure is there's a sort of kind of narrative when people put things in to say, oh, the pollution will only be bad for 6 months or up to a year. But in that time, someone can get asthma. And asthma is a lifelong chronic condition, and it can be fatal, as we know. And I think what the respiratory teams are concerned about really is more experts, better medicine, and yet the number of children who die from asthma has not gone down. In London, it remains between 8 and 12. And around the nation, it's about between 24 and 26. Those numbers haven't gone down despite everything. So for example, a quarter of 1 million children between 5 and 19 in London have asthma. Before 5, you don't tend to get a diagnosis. So that's what the foundation is doing. And going forward, my family and I, we're going to be working with Oxford University, and we're going to be looking at the genetics, and we're going to try cleverly to include some of Ella's DNA in that. I mean, it's not fully how we're going to do that, but it will be really good to look at her siblings plus her and to try it, because I think we've come to the conclusion they are more susceptible to the impacts of air pollution. Why? I don't actually know. And I think as their mum, I would also like to, there's always been a conversation, is there, for instance, an asthma gene? And that has never really been answered. So I'm not saying everybody isn't impacted by air pollution. Everybody is to some degree, but it seems that some people seem to be impacted more, and maybe it might be, it sort of moves the conversation forward, if you see what I mean. And
you've covered, sorry to interrupt, you've covered a huge range of issues there, and I just wanted to come to one specific thing which you raised, which is that air pollution is invisible. And I remember, you know, when I was a young environmentalist thinking, well, you know, even if people don't care about the climate because it's big and far away, surely they care about what they're breathing in. And it always struck me, and now as a science presenter, you know, trying to make programs and that kind of thing, trying to convince people that air pollution is interesting, and it always comes back to the fact that you can't see it. And so I was interested in what you said about art and how art could help make it visible. Tell me a little bit about how people are responding. How does art help people respond? Have you got examples where it's really
I'm part of the project in Lewisham. It's called Breathe 2022. It hasn't launched yet, so I can't really sort of talk too much in detail about it. But it's to do with activists, but it's actually making breathing sort of live where people can see it. But, you know, as a science presenter, I'm sure we will get there. One of the reasons why I think water is very effective is people can see dirty water. At the moment, you can't yet see, you know, the tiny particular matter. When I was talking to Stephen Holgate, they're sort of smaller than sand. So if you sort of, you know, and it's impossible to see that with the naked eye, but I am always hopeful. For some people, seeing is believing. But I do think in areas maybe like the South Circular, if there's a kind of way of, or maybe on some of the bridges, I don't know what, if you have actually on there what people are, you know, like the amber, you know, the traffic lights. I'm such a teacher, you know, so sort of the green cross code. So everyone knows red is terrible. Everyone knows that amber is on the way, or have them at bus stops and things like that. But the other thing to also mention, Helen, to me is I'm really interested in the whole monitoring sort of debate, because the monitoring, maybe it's proved, maybe it has improved since the inquest, but I wasn't really impressed at the inquest when I was listening to the monitoring around the country, by the way. I know people come on and they say, oh, we've got that tech and that tech, but when you actually when it came down to an actual inquest, and where the evidence was really important, a lot of the monitors weren't working, they all sorts of things. And still, when it comes to ultrafine particles, the really, really tiny ones, there is nothing that actually monitors that. So although people, you know, that is the one that gets through into the bloodstream and things like that. And also one of the things to mention to people on here is when Ella was ill and she had many tests and x-rays, we didn't actually see how bad she was inside until she died and there was a post-mortem. So I'm wondering again, even when you go to hospitals, how much of it is actually, you know, the invisibility. I remember at the first inquest, when they said she looked like she'd been smoking, I sort of looked over at her consultants like, what do you mean? Because we'd seen many x-rays of her lungs, and it's really interesting, not until she passed away and you opened her up did you really get to see the damage. So making the invisible visible is going to take time, but it's something we need to continue. And as a presenter, if you ever find a way as a science presenter, do drop me a message saying, yep, I found what can do it. That is really, really, really important. But I say, if you can smell it and you can taste it, then guess what? It means it is there.
Yes, and I think there's a call there for, I mean, engineers and scientists are working in this, as you said, they are very tiny particles, they're hard to detect. And I think people, there's a lot of effort going on, but then getting that cheaply enough and into the streets, it is taking time. But I think that your voice in pushing those people to do better is very important. So I was wondering what you would, you know, we've got a broad audience here who are listening to you. We all know the story of your daughter. We're all grateful that you are such a strong voice on this issue. What can they do? Because people always say, well, what can I do? You know, this sounds terrible, but there's all this pollution. It's kind of from far away, and I don't really, you know, what. Not only stage one is that it affects them, but then what can an individual do? What do you say to those people when it comes to what can they do?
There are some things to do with atmospheric. I was talking to my friend Nathan yesterday, and he lives in the Isle of Sheppey, and a lot of the pollution there, they can't do anything about. But I must remind people that even during the first wave of the pandemic, in London, the PM didn't go down. So nitrogen dioxide went down, and obviously transport we all know about. And the whole debate about wood burning is now becoming toxic. Another look, people aren't being told, you know, this whole nanny state, or, you know, look, it is carcinogenic. And someone sort of wrote to me about clean wood, and I sort of responded back in my usual kind of sarcastic way, like, what, a bit like clean diesel, because they tried that for a while. They were going to roll out clean diesel, and I think they just realized that it is not going to wash. So there are things we can do. And look, I know that, you know, I always have to be careful when I speak now, because there are areas of the country where the transport isn't like London, and even the further away from the central you move, sort of like Kent and areas like that, the transport isn't as good. And I repeat again, the government really need to invest in public transport. They need to make it cleaner, reliable, and more people would use it. There needs to be a public health campaign about the impacts of air pollution and things like idling. I mean, how many times have we been going on and on? I mean, wood burning, idling, short journeys, and I am very aware, before someone from the disabled community, my daughter was severely disabled, so I know not everybody can walk and cycle. So I have heard that message loud and clear, but many people can, and especially short journeys where you're going to the corner shop or things like that. We do need to look. I am aware we are a bit fair, we're a bit, I will call us fair weathered cyclists in this country, let's be honest. We're not like Amsterdam and places like that, but we do need to try. We really do. And actually my opposition on the other end is really the economy, and I do understand that the more the economy is ramped up, people get their cars and things like that. But as look at what's happened, and I haven't really been paying that much attention to the war, only because of Ella's anniversaries happened at the same time, and it was all a bit too much. But the fact now, I've heard the government say that we need to stop relying on Russia and places like that. Cannot ramp up renewables quick enough. We do need to find alternative sources, and all these things do actually matter. But as individuals, we also need to be led by governments, because that's what COVID showed me. Whenever the government said we need to do something, a lot of people tended to follow. So they really need to lead on this matter. And I am really pushing for a public campaign about the detrimental impacts. Look, COVID has showed us people care about their health, and I think if we, you know, from a teacher point of view, if we educate everybody about this, I think people will understand, and people will do something. Look, who wants long COVID? And I sort of worry now about areas of, you know, hotspots with people with long COVID and what impact that's going to have. So I hope my daughter's death, the positive to come out of it is it will ramp up some more and more action, because there are a lot of children who are still suffering especially in cities. But we can do, you know, it's just things like, I think most people, you know, when it comes to primary school, I think we probably live one of the furthest away from our primary school, about 2.2 miles, but a lot of people live close by and things like that. And one would always encourage, which is the right word, rather than wagging their finger, for people to walk to schools, and also those that do take their car, is not to sit outside the school and leave your engine running. But my advice also to people is, we've noticed the further away you are from the pollution, the better. So is to, where people can, to take routes away from the main roads. I always get a little bit nervous when I see these joggers jogging on the South Circular. I think, God, this is really not a great idea with all the lorries. So where you can, do take on alternative routes. Look, I'm not saying these things are easy. And, you know, you have governments that subsidize, you know, fossil fuel companies. That's a whole nother ballgame. But I think, you know, we can only do what we can. And as long as people are doing what they can, then that's all we can ask for, really.
I think you make a very important point about different types of crisis, that, you know, COVID was a crisis and the Ukraine is a crisis. And actually air pollution is also a crisis, but it's not seen in the same way. And I think that phrasing is very important, because we can act in response to a crisis. We've seen that. And I also think that the walking and cycling, it's such a simple thing, isn't it? It is something that, it's a habit that we sort of, people kind of gain the habit and lose the habit. And, you know, cycling in the rain, you get a bit wet, but that's what towels are for. So we have just only a couple of minutes left with you, Rosamund. And I was just wondering, what you know, what are your messages? I mean, what you're clearly going out, you've got so much to say to the world. What are the things that you want people to hear most? Like, if you got to walk into the Prime Minister's office or something, what would you tell him?
I've been trying to meet.
I would love to see that meeting, by the way, but
it hasn't happened yet. Mr. Johnson, you know we need to meet to discuss these matters. That hasn't happened yet. Look, I just want people to know how deadly air pollution is, and not obviously Ella was the extreme case. I do admit that, but well, we are living longer. Well, some are living longer, depending on, again, where you live. I mean, I am absolutely shocked. You know, when I did my master's years ago, I covered inequality in health. And I am ashamed to say air pollution wasn't one that I actually covered. But I just want people to know that it affects us on a daily basis. So we might not all get asthma, we might not all get dementia and things like that. And I know as a science presenter, you might say to me, what has made you come to that conclusion? Probably COVID, and how I think they will end up, well, let's wait and see how the public inquiry goes. If you lived in an area of high air pollution, the severity of COVID is what I'm talking about. But I just want people to know that it affects them on a day-to-day basis. And to let industry know, if the air was cleaner also, people would take less time off work. They wouldn't get as ill because it is linked to health in a way. But it's something, although you can't see it with the naked eye, I do want people to take really seriously. And we can't have a whole generation of children being, you know, 250,000 children in London at some stage or the other are on salbutamol. Asthma pumps. That is not really acceptable. Look, we've got one of the worst death rates in Europe to do with asthma. And I think from where I stand, as long as children continue to die, and to leave you with the message, and for people to take that in, is during the first wave of the pandemic, between March, 23rd of March 2020 and the 4th of July, no child in the UK died from asthma. So maybe people can ponder on that and wonder why, for the first time in forever really, no child died from asthma in that period. And when we resumed the economy on the 4th of July, by August, a teenager had died from asthma in London. So I will leave people to ponder on that topic as to why. Thank you very much.
Thank you very, very much, Rosamund. It's been a privilege to talk to you. For anyone in the audience, the Ella Roberta Family Foundation is out there that's supporting what Rosamund's doing. Do support it if you can. Rosamund, thank you very, very much. We really appreciate hearing from you. Thank you.
Thank you very much for having me.
Well, now we are going to hear from Dr. Hayley Pinto, representing Greenpeace, to talk us through the broader consequences of air pollution for human health. So, Hayley, the floor is yours.
Thank you very much. Thank you for inviting me. It was an absolute pleasure to listen to Rosamund's talk, and just the depth of what you know about this is, and what you're doing is amazing. I just quickly want to introduce my background first. So I'm a speaker for Greenpeace. I've also been an activist for Greenpeace. I'm a psychiatrist, an addiction psychiatrist by background, and I've recently left clinical work to work with the Centre for Sustainable Healthcare on making healthcare less of an impact, and seeing how we can contribute to the net zero goals. So I'm going to share my screen because I have got a few slides. Here we go. Can you see that?
Yes, we can. Thank you.
Brilliant. Okay. So as I said, I'm speaking today on behalf of Greenpeace, although normally I'm speaking on behalf of CSH. And I want to talk about the connections between air pollution and health. So just a little bit of science kind of initially, you know, what are the harmful bits of air pollution? We've touched on this a little bit already. There's the nitrous oxides, the ozone at ground level. Just say about 80% of the nitrous oxides in air pollution come from traffic. Ozone is obviously great if it's up in the stratosphere because it helps stop UV light coming through. So, you know, years ago we had the hole in the ozone layer and that was a problem. But at ground level, it's quite a toxic constituent of air pollution. And then, as Rosamund was alluding to, particulate matter. And these particles can become really, really tiny. And the smallest ones can cross the placenta, they can cross into the brain. So they really do get all the way around the body. And again, as Rosamund's mentioned, around 7 million deaths worldwide, premature deaths every year. So that's 1 in 8 global deaths, and 99% of people breathe air that exceeds the World Health Organization guideline limits, which is why it's been described as a public health emergency. And if we look at the UK, that's around 40,000 deaths a year. That's 110 deaths per day. And the people that are most at risk are the very young, the very old, people who already have heart and lung disease, and those who live or work in highly polluted environments. So why are children more vulnerable? Well, partly just because they're smaller. So they have a lower body weight, so what they breathe in, that's more toxins per kilogram. They breathe faster, they're closer to the ground. And because their bodies are still developing, they're more susceptible to the poisonous effects of toxins. And a study a few years ago showed that children in Tower Hamlets have up to 10% less lung capacity than the national average because of air pollution. So the damage from air pollution starts in the womb. As I've mentioned, particulate matter can cross the placenta with, impacts like lower birth weight, premature birth. So these things can impact a child's health then all the way through their lives. Higher rates of stillbirth and organ damage. And then in younger children, developmental problems, wheezing, coughs. And then as they get older, the development of lung disease, asthma, and even the start of atherosclerosis. So that's the furring up of the arteries that causes heart and other sort of blood vessel disease. And then it continues through the lifespan. So, as adults, again, impacts on lung function, also type 2 diabetes, heart attacks, lung cancer, and in older people, all of those things, as well as an increased risk of dementia. So if we look specifically at asthma, air pollution has been shown not just to make asthma worse, but also to cause new cases. It can also make people with asthma more sensitive to other asthma triggers, things like molds, which occur in sort of damp houses, pollen, dust mites, pets, etc. And spikes in pollution lead to increased attendance at GP surgeries, A&E departments, and hospitalisation. And looking at other forms of lung disease, so chronic obstructive pulmonary disease, which used to be thought of very much as the disease of smokers, can also be caused by air pollution, and is also the in terms of lung infections. Air pollution increases the risk of both bacterial and viral infection, and there's also evidence that it may cause changes in the lungs which increase the risk of antibiotic resistance, which is increasingly a problem. And obviously people who are chronically exposed to air pollution may already have COPD or asthma, which means that they're more at risk if they get a chest infection. Again, as Rosamund alluded to, there's evidence that chronic exposure to air pollution increased the risk of death due to COVID, both directly and also indirectly by causing conditions which increase the risk during COVID infection, things like obesity and diabetes. This doesn't want to move on to the next slide. Sorry, my computer's just taking a moment. So I think the next slide is about, ooh. Okay. Sorry, I don't know what's going on there. I'll share that again. Okay, can you see that now?
Yes, we can see that, yeah.
Okay. Sorry, my computer just crashed and it doesn't want to go on. Ah, here we go. Right. Okay, so I wanted to just share this this video, which I'm hoping will play. Doesn't seem like it wants to. Once my computer's settled down, I'll perhaps try and come back to that. I was mentioning obesity. It seems like a kind of odd thing. You think, well, why would air pollution increase rates of obesity? Well, basically, there's evidence to show that it actually slows people's metabolism. It also makes people less inclined to get outdoor and exercise. So in the United States, there was a study which showed that the risk of diabetes really increased substantially above this, 2.5 size particulate matter. And in 2016, they showed that there were about over 3 million extra cases of diabetes and over 8 million years of healthy life lost due to air pollution. And just have another go and see if I can get this to play. No, doesn't look like it's going to. Okay, just because I can't get this video to play, there we go. Let's see if it's going to work.
I have actually seen a change in the color of the lungs of my people. From about 30 years back, when I used to see mostly pink lungs, these days I hardly see any pink lung. There is a lot of silent damage that is occurring inside our body, to our lungs, to our heart, brain, every organ in the body. Unfortunately, it does not come to attention in the initial stages, but by the time it comes to attention, it's too late and you cannot undo the damage which is already done. Lung cancer has been my topic of interest. In 1988, when I started operating, I would see mostly smokers. So about 80 to 90% of these patients were actually smokers. And if we see a non-smoker, we would start wondering why this person has cancer. So we used to equate lung cancer with smoking. But recently, we were shocked to find that in the last 7-8 years, the distribution between smoker and non-smoker is 1:1. So we are seeing as many non-smokers as smokers. And another disturbing finding is that we are seeing patients in younger and younger age group. So I have many patients in 30s and 40s, because earlier the exposure used to start at say 20 years of age when you would start smoking. But today the exposure starts from the first breath of your life. So a child who takes birth in the city of New Delhi, going by the air quality today, on the first day of his life, he will inhale about 15 cigarettes. Another disturbing trend is that we are seeing more and more women. So there were very few women lung cancer patients earlier, but now in the recent study, nearly 40% of my patients were women. Therefore, every one of us, each citizen of this planet, has a duty towards taking measures to control air pollution. Because if we don't act immediately, it may be too late and we'll have to pay a very heavy price for that.
Well, I'm glad that could play, because I think it's quite powerful. That was just to give a bit of global perspective. There was as you mentioned, a surgeon from New Delhi, where obviously pollution levels are extremely high. So what about mental health as well? Rosamund mentioned dementia, but there's evidence to show that chronic exposure to air pollution also increases risk of neurodevelopmental disorders, things like autism and ADHD, of depression, anxiety, increases suicide risk during spikes in air pollution. And there's even data now showing that it's associated with increased risk of schizophrenia and also bipolar and personality disorders. So there pretty much isn't a mental health disorder that isn't potentially caused or made worse by air pollution. Rosamund mentioned social justice, and again, to make the point that it's the poorer populations that are more exposed, even though they're less likely to be contributing to the problem. And in terms of ethnic groups, disproportionately, it's Black communities who are more likely to be exposed, although by the raw numbers, there's more white and Asian people who are exposed. And, thinking about, what makes things better. Again, Rosamund mentioned health inequalities. These are growing. The Marmot report came out in 2010. There was a 10-year-on review a year ago, and those inequalities are getting worse. And that's not just deaths. So, for men living in certain parts of Glasgow, they're likely to die 25 years earlier than the national average just because of where they live. So that's years of life lost, but it's also years of life lost due to living with chronic illness. And what we know is that access to green space reduces health inequalities. It also helps to reduce levels of air pollution, but it's the most affluent areas that have the most access to green space. And we know that in London, we have, this is a very recent report showing that the air quality around every hospital and medical centre and care homes, in fact, in London exceeds WHO limits. So, although ULEZ was a step in the right direction, the UK is definitely lagging behind other European countries in terms of what we're doing about this. If you look at the Netherlands, 27% of journeys are made by bicycle versus 2% in the UK. In Norway, over half of new cars are electric vehicles. Almost all cars are banned in Oslo. We're a million miles away from that. Of course, linking again to climate change. So, what we're seeing globally is an increase in the severity of wildfires. And sometimes these fires are so big, the smoke is drifting across entire continents. And wildfire smoke contains obviously a huge amount of the pollutants that we talk about, things like black carbon, particulate matter, carbon monoxide. So that's also having an impact. And increasingly, if we continue to do almost nothing about climate change, that will be an increasing problem. And I want to mention as well indoor air pollution, because that's 7 million people dying prematurely as a result of air pollution. That includes indoor air pollution. And again, this comes back to a social justice issue. About 2.5 billion people over the world are cooking over sort of solid fuel or kerosene stoves. So 4 million of those 7 million deaths are actually due to indoor air pollution. And half of them are occurring in children under the age of 5. A disproportionate number are occurring in women who are more likely to be inside doing the cooking. So that exposure to air pollution doubles the risk for childhood pneumonia, which is already one of the top 4 killers of children globally. And in the UK, other forms of indoor air pollution are also important. Obviously, secondhand smoke and as was mentioned earlier, log burners and open fires, but also damp and mold. So a lot of people on low incomes are living in inadequate accommodation that's cold and damp, and that is contributing to their lung diseases as well. So, when we think about how all of these issues connect up, one of the things that we absolutely need to do to get our energy use down to tackle climate change is to make sure that people's homes are properly insulated and warm with the appropriate degree of ventilation. Poorly installed insulation can actually make damp worse. But that would improve the quality of life so much for so many people, and not just their lung health, but also their mental health. Living in conditions like this, is pretty depressing. So, that brings me to the health co-benefits of action on climate change. Looking at this more broadly, it's almost why wouldn't you do this anyway? Because, as I say, insulating people's homes, that improves their physical and mental health. It also makes their homes cheaper to heat, which means they've got more money, for example, decent food. Improving our diets through more locally sourced plant-based foods. That again has been shown to improve physical and mental health. And there's lots of studies. So, there's a case study I was looking at recently in Tower Hamlets, where they there's big blocks of flats, and the community put in some shared veg beds. And it wasn't just that they were then having access to a bit of green space; they were having access to fresh, nutritious food. But they were also saying, well, when we come down to the veg beds, we talk to each other. I've lived in these flats for 5-10 years. We don't talk to each other. Now we talk to each other. So it can really help to build community and tackle social isolation as well. And of course, walking and cycling, as well as getting air pollution down, it makes us fitter. It helps to tackle the obesity crisis. And also exercise is really good for our mental health as well as our physical health. So, there's all of these potential benefits to doing things that we need to do as an act of self-preservation to tackle climate change. Just to mention briefly, because I am speaking on behalf of Greenpeace today, some of the things that Greenpeace has been doing. So we've been involved in air pollution monitoring, following I don't remember you, I'm sure you all remember Dieselgate a few years ago. The commissioned independent assessments of diesel vehicles. And this is another just short video from Greenpeace that I just want to share with you, since my computer's now.
Why are so many people trying to get diesel cars off our roads? What makes them any worse than petrol cars? And why should we care? Let's get the science bit out of the way first. In order to burn fuel efficiently, diesel engines have to generate high temperatures and lots of pressure. This causes the oxygen and nitrogen in the air to react, which results in the creation of a gas called nitrogen dioxide. Nitrogen dioxide is really harmful to human health. It's known to cause respiratory conditions like asthma and stunt the development of children's lungs. Nitrogen dioxide also contributes to the production of something called particulate matter, which is a very dangerous mix of extremely small particles and liquid droplets that gets into the air. When we inhale this particulate matter, it can cause serious heart problems, including heart attacks. Doctors are calling it a health emergency, and they're telling us we need to get diesels off our roads for good. So if diesel is this bad, and people know it's this bad, why do we still have it on our roads? Companies like Volkswagen are trying to convince us all that dangerous diesel cars still have a great future. And they're doing this because if diesel dies, they stand to lose a lot of money. And how do they justify risking our health to keep lining their pockets? They argue that we should put up with cars that have been linked to all these health conditions because they're supposedly better for the climate. But is that even true? Do we really need diesels to keep CO2 emissions in line? And are they any better for the climate than petrols? Let's examine this, shall we? Say you take a 1.6 litre petrol Golf and a 1.6 litre diesel Golf and drive for 10 miles. It's true that the diesel Golf will emit less CO2 than the petrol because it burns less fuel. But if you take into account the entire life cycle of a car, then the CO2 burnt for every diesel is pretty much equal to that of a petrol. And that's because you have to burn more CO2 to make a diesel car than you do a petrol one. And refining diesel fuel uses up more CO2 than refining petrol does. So, despite what the car industry says, when it comes to the climate, diesel and petrol cars are actually just as bad as each other, which is why the real solution isn't for us to put up with dangerous diesels, it's for car companies to go electric. So there you have it, diesel. It's really bad for our health and it's no good for the climate either. The quicker the car industry ditches diesel and transitions to electric, the safer we'll be and the healthier the planet will be too. Thanks for watching. Subscribe to our channel for more.
The only thing I would take issue with that particular video is the idea that electric vehicles are the answer. They're not, for a number of reasons. They're part of the answer, but certainly not the whole story, which is one of the reasons why Greenpeace is pushing for the government to allocate 10 billion a year to offer free travel for the people on the lowest incomes. Worth saying that, you know, about 65% of people on the lowest incomes don't have a car. So they're not contributing to the problem. They're also more likely to live in areas where they don't have access to public transport, which is a real problem. In fact, about half of small towns in the northeast and southeast are considered transport deserts. So Greenpeace wants also some of this money to restore the bus routes that have been cut since 2014 and start adding new routes. You know, we need more coverage, particularly in rural areas. We need to expand and improve the rail network, and we need to increase not just the infrastructure, but support for people to be walking and cycling. So, you know, that's money really well spent, both in terms of our health, both in, you know, in terms of the impacts on climate change. And the reality is at the moment, we're spending that money subsidizing the aviation industry, which means that rather than, you know, being able to travel cheaply on buses and trains, you know, we're left with a service which is inadequate. You know, we've all had that experience of waiting for a bus that didn't come, having the train cancelled. You know, you can fly to Barcelona for literally about 1/10 of the cost than you can take the train from where I live across the country to Liverpool. So Greenpeace is also has on their website a beginner's guide to city cycling, again, to kind of help support people to kind of get their confidence back in terms of getting back on a bike. So that's it from me. Very, very kind of broad brush, quick sort of spin through the health impacts of climate change. So I'm going to stop sharing my screen now and hand over to Helen for questions.
We do have time for a little bit of questions. We haven't been given any. No, so if people out there listening, if you've got some questions, do stick them in the Q&A chat. I do have one well, I've always got lots of questions, but one for Hayley, which is just to dig a little bit more into the electric vehicle thing, because there is this feeling, I think, it's always easy to swap one thing that you've got for another thing that looks the same, but just is magically better. And it's a bit more complicated than that with electric vehicles, isn't it?
Absolutely. So, you know, people talk about them as zero emission vehicles. That's nonsense. You know, if you look at the whole life cycle of that vehicle, you've still got to extract all those resources, some of which are rare. In the process of doing that, often impacting the health of communities where you're extracting those resources. You've got to manufacture them, transport them. So there's a huge amount of resource and carbon emissions wrapped up in that vehicle before you even do anything with it. And if you then look at the fact that the average car in the UK spends 96% of its time parked. You know, think about buses, trams, trains. You know, for rural areas, we need to be more demand services rather than easily you can link from the bus to the train or whatever. That's how we get the number of vehicles down. And also there's the fact that when you're driving that, you know, an electric vehicle, there are still emissions from the tires, from brake wear. So, you know, this fantasy that we can just, as you say, switch to another version of the same thing, and we don't have to change our lifestyles, it is a fantasy. You know, we have left it so late with climate change that we have to change, and we have to change fast if we're going to have, you know, bequeath to our children a world that's actually safe for them to live in. So, you know, we've got to kind of just get rid of these kind of fairy tales that we tell ourselves that actually we don't need to change our lifestyles. We do, but the good news is it can actually make us happier and you know, have better quality lives. You know, spending less time sat in traffic, breathing in diesel fumes, more time at home with your family, more time with your friends, more time out on your bike getting fit and, you know, breathing in fresh air. That there's actually a lot of positives here. We shouldn't think of it always as a negative, but certainly, yeah, the idea that, and also, you know, we've got to power down a bit to be able to power ourselves with renewables. If we just switch the whole fleet over to electric vehicles, that's going to be a real struggle, isn't it?
So I'm going to add a plug here for some of my own work on tire particulates, actually. So I do some work for a YouTube channel called Fully Charged, and we made a whole episode about non-exhaust emissions. So electric vehicles, let's not mince words. If you're going to have a vehicle, an electric vehicle is definitely better, but it's still got some things we need to think about. So there was an issue on tire particulates on Fully Charged, if anyone wants to learn more about non-exhaust emissions. And I have a question for Rosamund as well before we go to the Q&A, which is, in your local area, Rosamund, on the streets around where you live, are you seeing any improvements at all in the past 9 years? Has anything got better, or do you feel it's all just where you are, it's just kind of stuck and everything's the same?
That's an incredibly sore topic with me, because the road that contributed to my late daughter's death is actually, in fact, worse. Yeah, that's a really sore topic. I mean, there are patches of it which are better, but can I please take the opportunity to mention about the government's consultation, because I don't think people will forgive me, on particulate matter that should be out this month, that people need to engage in it. The government are going to be using that to set targets. And if those that have read the coroner's report remember that he particularly mentioned the particulate matter, that Helen, brilliant presentation. I have actually messaged you. I'm after Helen's video. I always do this when I go into these things. That we need to engage, please, in the consultation. It's probably going to be out for about 8 to 12 weeks, but it's incredibly important that all of us, and also we use our networks to share it and get the public at large to engage with the engagement on PM 2.5, please. It is really, really important. As we all know, the Environment Act was passed last year. I can't stress how important this is going to be. So please, could everybody, I mean, everyone who's on this call now, I assume obviously in some shape or form is engaged already with the matter of air pollution. So if people can share it, I mean, it's got about maybe 60, 70 people here, and that will, we need to really work on that and get the wider public. We can't just say it's just us in this environment. This air pollution really needs to be spoken about on the same level as COVID. So we definitely haven't got there where everybody is talking about it. And you know, between Helen and our presentation, you can see that so many more things need to be done. And I was very much taken when Helen was talking about walking and cycling, because my 3 children, including Els, started cycling very early on. And maybe something for us to do, because it's to do with a whole the behavior change, is maybe introducing cycling lessons in schools where it can take off. I don't know what Helen says about that, but I do say though, as a mother who's lost a child, I still have slight hesitations about my twins cycling. I mean, they're going to be allowed back on their bikes now. And when you say back on their bikes, people go, what do you mean? When it was dark at 4 o'clock, I really couldn't get them on, you know, I had to ask them, now is the time to come off your bikes, guys, because you know, it's just too dangerous. But it's getting lighter and they will be back on their bikes. So as a nation as well, those that drive, and Helen's very right, you know, there's about 38 million cars on the road. So if you swapped every single one of them for electric vehicles, that is not going to solve the problem. And she's already mentioned tire and brake wear, so I'm not going to be going over it. This idea that you can swap, look, things will be better. Let's be honest, let's not lie, but it's not going to solve the problem ultimately.
I think it'd be great to see more kids. Actually, so when I remember in primary school, I had cycling lessons. That was a thing that the school did back in a few decades ago now, but it did happen, and it would be, you know, I'm sure that it would be a great thing for cycling safety as well to happen again. So I'd like to pick up on a question here for Hayley that Matthew put in the chat, so I'm going to read it out, which is how you mentioned that there are people in the third world, often women, cooking over fires indoors, which is a problem we don't hear a lot about in this country. I hear a bit about it because I hear engineers trying to solve this problem. But Hayley, how do we help those people? You know, that's a what you're talking about, billions there. That's a huge problem. How is there anything we can do to help?
On a kind of simple practical level, there are organisations which are you know, delivering clean cook stoves to women. So, you know, look out for things like Practical Action, who are doing that. You know, the other aspect, and again, this comes back to climate change as well, but also huge social justice issues, you know, in terms of women having access to education and family planning, you know, that's what lifts them out of poverty. You know, that means that they then have fewer, healthier children. That means they're not then stuck, you know, cooking over a dung-fired stove. You know, those are things which are about, you know, just wider aspects of gender equality and you know, sort of class, if it will, you know, economic equality. You know, so supporting organizations that are doing that sort of work, because, you know, you've got to remember that, you know, in the low income nations, about 40 to 80% of food is grown by women smallholders. You know, they work harder than probably anyone else in the world. We sit here and say, oh, well, you know, I've earned this, I've worked hard for it. No idea, these women are working really hard, and climate change is making that so much harder for them. And if they've then also got lung disease or heart disease or a combination of both, you know, and it's also affecting their mental health on top of all of that, because they're breathing in these fumes. You know, it's just all of these different kind of, you know, risk factors and vulnerabilities all intersecting to make things so much more difficult for them. So, you know, supporting those organizations that are working in the low income nations to, you know, as I say, help increase women's access to education, but also those clean cook stoves. There's a lot more I could say about that, but I'll stop where I'm doing.
Well, people can perhaps do a little bit of research now we've raised the issue. So we're almost at the end of our time. We have one more question for Rosamund, and it's from Sam Oldham. Sam, would you, when you're unmuted, please would you ask your question? And if you could be quite brief in your answer, Rosamund, because we're just coming up to the break, that would be great. Sam, are you able to speak?
Yes, sorry, can you hear me?
Yes.
Thank you. My question was just a really quick one, was that you mentioned in your presentation that you are lobbying the government, and given that they're looking to change, maybe backtrack on some things. How is that going? How's it being received?
Well, I constantly have open dialogue with the government. I have asked to speak to the Air Quality Minister. It's an ongoing process, Sam. It is not easy. I'm not going to pretend that. But in the same way, in my role as Brief Life Ambassador, I'm going to be lobbying mayor in cities. And I'm sure we've got a local council around the corner as well. Look, it is not easy. And we all know why. The whole thing about fossil fuels is a much bigger picture. And I think COP brought it into our homes, you know, the whole thing between phased out and phased down. I'm sure you know what I'm talking, but I will continue. I mean, I'm not going to stop, but I'm not going to pretend and say, they agree with me, by the way. They say to me, you know, you've made the health argument, you don't need to convince us, but I find action is really slow. But then my daughter did die, so no action is ever going to be quick enough for me. But as long as children continue to die, and that's why I'm trying to get the people from health on board this as well, because I do know that governments listen to doctors and things like that. So that is my strategy regarding that. And we have got Chris Whitty, the CMO, who's going to be writing a report later this year about air pollution as well. So it is definitely not easy. I'm not going to pretend that it is easy, but I continue on this journey, Sam. So I'm doing the best I can, but I am met with many obstacles. You know, the government, the government know what I'm saying is true, and they know the country. You know, we have such a long waiting list on the National Health Service, and yet they're dragging their feet. I mean, I've really got to say that they really need to come and start acting a lot quicker. And, you know, I am aware of the time, so I'm just going to leave it at that. But I continue to pursue things with them, yes.
Well, thank you very much. And I'm sure that making a fuss is something that we can all do. And the more of us make a fuss, the more things might change. So we have come to our lunch break. Thank you to everyone who has joined us this morning, but don't disappear completely, because there is lots more this afternoon. We'll be talking about electrification and decarbonisation, so how we do things differently. And then at the end of the day, a really exciting session on cities. What do cities look like now? What could they look like in the future? What are the trends to do with air pollution in cities, and how can we reimagine our cities? Because I think a large part of this is having a mental image of what we're aiming for. We need to be able to imagine what a better future looks like. So having said that, I will let you all go to lunch. Thank you so much to both Hayley and Rosamund. It's been a privilege to speak to you both, and we will be back after lunch. Thank you.
Thank you for having us.
and welcome back to the afternoon session of this Green Tech event. So I hope lots of you from this morning have rejoined us. If you weren't with us this morning, I'll just run quickly through how all this will work, and then we'll get going on this afternoon's talks. So this afternoon we have a couple of sessions, one on electrification and decarbonisation, and then a tea break, and then one on cities, on comparing London and Beijing, past, present and future. So there are lots still to come. So the way this works is that each pair of speakers will speak for 20 minutes each, and then we will save questions until after they have both spoken. So you will get to ask questions of both speakers, but we'll do all the questions together at the end of each session. Now, what that means is that the way to ask questions is to put them in the Q&A tab in the bottom of the Zoom call. So there is a chat tab, feel free to do some chatting, but if you've got questions, please put them in the Q&A one only, and keep them short and make sure they're questions and not comments. That'd be great. And you can also tweet along if you'd like to tweet about this event, and if you'd like to do that, the hashtag is hashtag the future of green tech, all one word. So I think that is all the, oh yeah, you can be putting your questions in the Q&A tab as the speakers are going, but we'll only get to them at the end. That's the other thing. Okay, so let's get going on decarbonisation and electrification. That's the topic first thing this afternoon. And first up, we have Louis Grove from myenergi to get us started on electric transport and how it fits in with everything else. So Louis, the floor is all yours.
Thank you so much, Helen. Right, so let me see if I can share my screen effectively. Right, can we see this?
Yes, that's fine.
Excellent, thank you so much. Right, so my name is Louis Grove. I'm with the strategy team at myenergi. So my background is in kind of social research. I'm social anthropology originally, as well as from previously more sort of like bioinformatics around evolutionary biology, bit of a random history, but it's my job to sort of conduct the research at myenergi that goes into increasing the adoption of renewable energy technologies and electric vehicles. So I'm going to talk you through a little bit about why we think that electric vehicles are a key part of the decarbonisation of transportation, especially relative to ICE vehicles, but even the hybrid, the plug-in hybrid or non-plug-in hybrids. And then I'm going to talk about a little bit about heat as well, as that can play a role in the kind of emissions that we see over the UK, but in particularly in London. So decarbonisation of like the whole home energy ecosystem, and then I'll talk a little bit about how all of these solutions fit together, how they can help with the uptake of renewable energies across the grid, etc. So first off, so this is just a little overview of myenergi and who we are and what we do. So we think of ourselves as the providers of the whole home energy ecosystem. So these are a little bit about our products. So we make electric vehicle chargers as one of our best-selling products. They are all network connected, all smart. That is kind of the ethos of our devices, and they're all future ready. We have the hub, which provides the network connection for all of our devices, and I'll explain why that is important in a little bit. There's the eddy, which is a solar power diverter. So what that does is it takes energy from your solar panels, excess energy, and converts that into thermal energy in a hot water tank. I'll explain why that's important as well. And then there's the Harvey, which gets rid of all the cables and stuff. And what we end up with, with all of these solutions in the mix, is that you can monitor your energy consumption across all of your devices at home. You can see how much renewable energy you're saving. And we find that people who actively see where in the home their energy is being used, they think about it so much more and become so much more conscious. So we are about promoting the self-generated electricity, but also the renewable energy devices. So why this is important. So the energy landscape is changing. This is not, this shouldn't be news. So the global, so this is a look at how the the solar photovoltaics is increasing. This is like the capacity that we see across the UK. So this is showing just quite how much we're going to see solar as a part of our renewable generation. We can see different energy scenarios. So up to 2030, if we lead the way, this is all the scenarios that we see in the BEIS. So there's multiple different ways we can get to increased renewable generation. Some of these scenarios say have us at 60% renewable generation by 2030. Some have 96. What we want to try and do is increase, get as high a proportion of that energy production in renewables as possible, and we'll see what we need to do to get there. So European EV uptake as well. We're only hear about just under sort of like 7 million EVs on the road at the moment. To get to this kind of level that we'll need to see to get those most ambitious scenarios, the uptake it's orders of magnitude over the next 10 years. This kind of gives you an indication of the scale of change that we're going to need to see. Heat pumps, this is one of the main ways that the government particularly see us decarbonising heat at home. We see that it's essentially going to have to double over the world by 2030 if we want to get there. The kind of housing stock that we see at the moment, it's not just new homes that we need to have these alternative heating options, but we've got to be able to retrofit this. This is what we're going to need to get to. That can't all be made with new homes by the end of 2030. So we have to find solutions that are going to work for houses that we already have. So it's a mixed picture. There's many different things we're going to need to do, and we'll see how they all fit together. So first off, we're talking about emissions within sort of like London, for example. So when we talk about emissions, a lot of the emissions that we talk about are produced by transportation. So it's around 30% of the total emissions of the UK at the moment are from transportation. So looking back at a representative year, so 2019 due to COVID probably wasn't the most representative year that we've had. So if we look at as was 2020, 2019 was representative, 2020 wasn't. This is the proportion that Londoners travel by each transportation method. So London has fairly good public transport. That's what we like to think. However, the average Londoner will travel much further in a car and a van than they will by any of the other public transportation means. So we think that public transport has a big part to play in providing the decarbonisation of transport in the future. But at the moment, it's almost 50% of miles travelled are done in cars and vans. So it's whatever the solution is going to have to be over the next 10 years, this is where we can make the biggest difference. If we can reduce the emissions of these parts of the transportation network, then that's where we'll make the biggest difference at the moment. So a little bit of an explainer on what we think of as low emission vehicles. So we hear this all the time. There's low emission zones in London where you can only go if you've got an ultra low emission vehicle. This is just to put into a bit of like context what the actual emissions impact of these different vehicles is. So an average petrol car, I think like a 1.8 Vauxhall Corsa is roughly what the average miles per gallon you can expect out of an ICE vehicle or an internal combustion engine vehicle. This puts out 142 grams per kilometre of CO2 or CO2 equivalents. So we're talking in terms of CO2 and global warming. These will be representative of the other kind of particulate outputs that you have from internal combustions. But this will give you a bit of information about the relative proportions there. If you have a fully plug-in hybrid, it will save you a fair bit of the grams per kilometre of like emissions. But not that much more. It's within the similar bounds. And if that's assuming that all these plug-in hybrids are plugged in and charged when they need to be, many people don't fully charge them, or they forget and get into the habit of forgetting. But even the very best plug-in hybrids, you can expect 57 grams per kilometre. It's even with these hybrids, we see them all around London. The Toyota Priuses, it's still a similar kind of fuel consumption, and it's still a similar emissions output. So while these like satisfy all of the low emission standards that we have, it's like just an extra. So for every 3 hybrids you'd have on the road, that's 3 Priuses. That's still like 2 other kind of ICE vehicles that's the equivalent. So only the fully electric vehicles have the capacity to reduce all emissions that we'd think of as dangerous within London. And even that, well, it's important that we see battery electric vehicles, fully electric vehicles, as the solution to our emissions problems. So what is the uptake looking like at the moment? We see the uptake of hybrids is this is strong growth. Over the last 5 years, we've seen a pretty strong uptick in plug-in in the more efficient car technologies. This is great, but to sort of indicate the scale of the change that needs to happen over the next few years, this is the relative proportions of these new, more efficient vehicles relative to diesel and petrol. So we've seen that most of the distance traveled by Londoners is by a car or a vehicle. There's no other directly replaceable technology that we have for those journeys that won't cause emissions, as we sort of understand them here, as the battery electric vehicles. And it's just less than 1% at the moment. So this is a big challenge. It's a big scale of the challenge and opportunity. But am I saying we're not going to get there? No. So this is a little bit more hope. We can see that as a proportion of the new vehicles coming online or being registered, the proportion of those which is electric vehicles is growing at a very fast rate. So in 2021, this is the latest data we have up to September, it was around 17–18% of the new vehicles. It's actually gone up. I think this last January, I had one-off data. It was around sort of like 20–25%. So this is the kind of growth rate. This is the proportion of new vehicles we need it to be. We need that to continue. But I think what I want to emphasize is that we can't let any barriers to this decarbonisation exist. If we see a barrier to the kind of adoption of these low emission technologies, we need to make sure that these barriers are removed consistently. So, essential infrastructure for adopting these technologies. This is the electric vehicle charge point. So I think maybe one of the most useful ways, so this is how you charge an electric car. One of the most useful ways to think about, I think I'm thinking about this, is the amount of miles that this delivers to the car for every hour or half hour of the vehicle that's being used. So range anxiety is a massive issue with the adoption of electric vehicles. Like, people think, oh, will I get to my destination? This is a serious part of the technology will address that and address the and help maximize the uptake. So we have the low charge. This is a regular socket that will charge your car in about 24 hours. The slow chargers, these are the kinds you see on the street. These are implemented by local authorities. So these lamppost chargers, they cost about £1,000 for each local authority. They take about they can take an hour to install. So they're rapidly distributable. They think of as destination charging. If you have these in your borough, it will make it so that electric vehicle drivers or people who own vehicles in the area, they know that when they drive home or when they come to visit people, they don't have to worry about the charging, and that will help the uptake. This is where we sit. So with Zappi is one of our flagship products with fast charging. This will charge in sort of like 2 to 4 hours. So if you have visitors and everything, everyone knows you can charge your vehicle in a short amount of time. that will help the adoption. And then there's these these are the kind of chargers that you see on the roadside. These cost hundreds of thousands of pounds each. Again, essential infrastructure. We need all of these solutions. The mix of these hasn't changed over the last few years, and every time there's growth in the number of national chargers, the growth is across all of these. We need all of these solutions to get rid of this range anxiety. Just to show you, so most people charge at home that have electric vehicle chargers. So ours is especially higher because we sell them. But most people charge at home. But most people, I'll move on quickly. Most people use a mix. All of these parts of the infrastructure are important. A lot of people charge at home. A lot of people charge in a mix of home and public. But all of these are important to provide to get those miles into the cars that will replace just burning stuff to provide that energy. So this is a little bit of context about why it's not just enough to have the technology or to have it make sense. This is we've conducted a lot of research into the adoption of these technologies. If you ask the general public whether they understand what is meant by the term climate change, whether so they understand it, whether global temperatures have increased on average, so whether they believe in climate change, whether human activities are responsible, so whether it's anthropogenic, whether humans have caused it, and then whether they'd be able to, whether people would be willing to pay a premium for services that contribute to tackling it. Only about half of people strongly agree that they understand what climate change is. So this is answering a 6 or 7 out of 7. Those are people. It's not that many people that even A, understand it, B, believe that it's happening, C, believe that humans caused it, and less than a quarter of people in the total population will be willing to pay a premium, so pay more for goods and services that will contribute to tackling it. This means that we need to provide these solutions in a way which is economical. We need to reduce all of the barriers there are to this technology being adopted for it to make a difference. There's great things which exist. So the O11, the OZEV home charge scheme, this allowed people to have a little bit of a subsidy for installing this necessary infrastructure for helping the adoption of electric vehicles. This scheme, so this helped get those miles into those vehicles for 80% of vehicle owners. The scheme was a factor in the purchase decision for the majority of these for these infrastructure owners, and it was highly important for all of these things. So these kind of schemes, this shows that the government supported schemes have a real impact in getting this infrastructure. There are like tens of thousands, hundreds of thousands of miles completed on the road by electric vehicle owners who've used these kind of schemes. We all just need to, I think, support all our local government, our national government in introducing schemes which encourage this infrastructure adoption. Do I have time? I've got a couple of minutes left, so I'm just going to quickly talk about heat as well. So heating and hot water is responsible about 15% of the UK's emissions. So it's a very that's mostly in residential, but it will have an impact in business and the public as well. So we see that heat pumps are seen as a big solution for this. There's reasons why we have to be a little bit hesitant. So it only operates at sort of 30 to 45 degrees Celsius. So there's a lot of infrastructure which needs to, your radiators need to be that much bigger if you want to heat your house with something that's only at 30 to 45 degrees. It's the size of a washing machine, so you need to have it outside or on a wall somewhere, and it costs 8 to 18,000 for an air source, or even more for ground source. Solar power diverters are another way to address this. They take excess solar energy, and they allow you to put that solar energy not just back into the grid, but back into heating your house. So around 80% of solar energy that people generate is usually excess that goes back into the grid. But solar power diverters allow you to use 100% of it to heat your home. They don't require all of these kind of so much space, and they decouple the energy production from the time of use. So you can produce energy in the day, in the afternoon when it's hot, and then you can store it for use later. Whereas at a heat pump, you can imagine it's pumping heat when it's cold at night, when you want to be heating your home, when it's also cold. So there's a gradient you have to there. Essentially, what I'm trying to say is that there's the increased electrification of the house through the heating and through the infrastructure. It needs to be considered that the energy that your house will require in total will increase. So we can see that if you turning your kettle on at the moment with your home energy input will be about 3 kilowatts peak. If you have a home which has an electric vehicle charger and a heat pump, which is the kind of necessary infrastructure we're seeing, that goes up to a 15 kilowatt peak. So over the next 30, 50 years, our electricity peak demand is going to increase, probably by over 60%. So this is where the smarts come in. So if you have smart devices that are all network connected, what you can do is you can turn down the load of those devices, the amount of energy they're using on a big enough scale that you can offset the peak that you see in the middle of the day. You can even out that demand over the full day. There's more technology that we see in vehicle to grid, where you have electric vehicles that they can charge when electricity is cheap, when it's plentiful, when there's lots of energy being generated by renewable energies that needs to go somewhere, that you can put into your car. There's new technology coming where that car can then put the energy back into the grid at periods of high demand. So so we see that with smart charging and vehicle to grid. This is taken from the government website. We can see that without the load balancing that we get from smart charging and with vehicle to grid, we have to expand their peak load capacity by that much more. But as long as all these devices are smart, as long as we get vehicle to grid in, we'll see that we don't have to invest as much on infrastructure. I think the dividend is about sort of like £10 billion we're seeing, with sort of like highly flexible devices that will change their energy requirements as needed over the next 50 years. So it's important that all of these devices are smart, connected, that they help the decarbonisation, and that we remove as many barriers as we can to the adoption of these sustainable energy technologies. It's going to talk about a summary, but then I think that's my time, isn't it?
Well, it's okay because we started a little bit late, but you finished pretty much on 21 minutes, so we'll give you that. So if you've got questions for Louis, hold on to those, or you can put them in the chat now while you think of them, or hold on to those for after the next talk, and then we will deal with them all together. As a reminder to everyone in the audience, you can be putting your questions in the Q&A box at any point, so do feel free to do that. So we will come back to Louis, but for now we're going to move on to Simon Pickett from SSE Energy Solution. So Simon, the floor is yours.
Hi Helen, thanks very much. Let me just get my screen shared and then we can go from there. Is that shared correctly, just to confirm?
Yes, that's fine, yeah.
Brilliant, thank you. And yeah, thanks Louis there for that. That's covered quite a lot of the statistics and acronyms that I would need to be covering, so you probably saved us a bit of time as well. I won't go through and repeat those stats and explain all those things. But yeah, those references are very useful, and I can certainly dig into some of the kind of commercial activities that are happening on vehicle to grid and beyond. So by way of a brief introduction, I'm Simon Pickett. Apologies if you're expecting Kevin Wellstead. He's unavailable at short notice, so I'm covering that today. And I'll give you a brief background on SSE first and foremost. My role is a project development manager, so ultimately I sit within SSE looking to deploy EV charging infrastructure, ultra rapid and fleet charging infrastructure across the UK and Ireland. So trying to solve those problems. And I think there's a fundamental link between deploying those solutions and air quality in cities and towns across the country. So joining those together. A bit of context on SSE. I'm sure everyone's probably aware or has seen the brand somewhere. There's a huge number of different businesses within our group organisation. We have SSE Renewables, so we are the largest UK generator of renewable energy, and we generate that energy and send that into the national grid. That energy is then distributed through the national grid to local DNOs, and apologies, some of you may know this in some detail already, but we also then run SSEN, so our networks businesses in the north of Scotland and the south of the UK, which then get that energy from those renewable and some cases non-renewable sources through the grid and out to consumers and businesses. And I sit specifically within the SSE Energy Solutions business and a distributed energy part of the business, which I will come on to in more detail in a moment. I'll try not to be too corporate with this, but to cover a few of our strategies and goals, because I think it's important to see why these big FTSE companies are getting so involved in sustainable energy and investment. So our mantra, I suppose, is to provide energy needed for today while building a better world of energy for tomorrow. And I think, you know, there's a real theme in the government policy and society now that we have to take action today, and that action today is focused on what we need to do for tomorrow in advance of tomorrow, and that tomorrow is too late. So important to call that out, I think, and our strategy, being a commercial organisation, has to be linked to shareholder value, but it's not all doom and gloom and money. There's that circle you can see in the middle on the screen, hopefully, which is the shareholder value allows us to continually reinvest. So we are investing in the technology today, and we can continue to use that investment to generate revenue to then invest again in the future. We are closely linked to the UN Sustainable Development Goals for 2030, and I'll only call out one of these and try and be quite quick, but we're trying to help accommodate 10 million vehicles on the roads. That is not to be interpreted, please, as we're trying to get 10 million more vehicles onto the roads. Quite the opposite. We're trying to convert vehicles that can be electrified. As was mentioned by Louis previously, the simple answer is less vehicles and less emissions, and that is the quickest way to improve air quality from an emissions side of things. Separate to the detail here, obviously, we are investing, and we've announced something called our Green Print, which is £12.5 billion of investment in green tech, which equates to about £7 million a day of investment. So it's eye-watering sums of money going into this sector, not just in EV. And there are 5 key focus areas. So we're focusing on having a net zero power system by 2040, which is fundamentally important because we need to electrify and ensure that carbon is removed everywhere within the system. Strategic investment in the networks, which is critical because if we don't invest in those networks, they will struggle to disseminate the energy across the country to allow people to electrify, which obviously in turn allows people to change from ICE vehicles to EVs. We're calling for a clean industrial revolution. I won't comment on the last industrial revolution, but it certainly wasn't particularly clean. This one has to be, we know that, and we're working to support that. We're leading the charge on EVs, so we're investing directly into EV infrastructure and the infrastructure that supports that EV or those EV networks. And to touch lightly on it, we're looking at green buildings for green jobs. So the electrification of heat and ensuring that the buildings that we work in and we support are green in themselves, because buildings obviously do have some emissions as well. Specifically within my business unit, we take a whole systems approach, and I think I know I'm sort of skirting around air quality, but it is all linked together because those whole systems interlink. So we're looking at building localized flexible energy assets, and ultimately the electrification of buildings and transport are integrally linked, and gas boilers and gas cars or gasoline, if you like, cars need to be linked together in not only the core energy infrastructure, but also in digital platforms and analytics. And without that data collection and that understanding of how those systems are working together, it's very difficult. It's very difficult with that data as well, of course. It's quite a complicated ecosystem. But actually, once you have that data, you can understand, and we've all seen air quality data and how it's localized, and that gives you an ability to drive down and look at where you need to invest in that infrastructure specifically to tackle the problems like air quality and pollution. Sorry, There we go. So just jumping into key focus areas for our business. I suppose, where are we helping? And help is a key word in this. We all need to work together. We all need to help each other as much as I've mentioned, kind of shareholders and commercials. I think that the sector in green tech itself is a very collaborative space, and together we will achieve this. Alone we won't. So we're focused on the electrification of buses and public transport, and I know Louis spoke briefly about that previously and the importance of the use of public transport. We have so far helped to electrify the majority of the fully electric bus depots in London, and until recently, and I don't have the up-to-date statistic, I'm afraid, but over 90% of the UK's electrified buses were supported by SSE activities up until about 2019. So we've been really involved and really pushing that agenda forwards and supporting those bus operators, and we continue to work with them across the UK and Ireland. The development of hubs and community fleet charging is something that will become more and more common across the country. I'm sure everyone knows various brands or has seen rapid chargers at service stations and other locations. That is absolutely going to accelerate. There's been challenges in the past around range anxiety, i.e. will the cars and vans go far enough to get you from one charge point to the next? The newest vehicles coming out, that's not a problem. That's fairly accepted now. We've moved through to a sort of charger anxiety situation, which is sort of moving through to a supply chain anxiety situation. So we're helping with that and using our group buying power to ensure that we've got the right things in the right place to deploy them as soon as we can. I think that the wider EV sector, not just SSE, is moving very, very quickly, yeah, the delay in some of the supply chain activities is actually helping us to deploy ahead of more vehicles arriving, which is both bad and good, I would suggest. We are practicing what we preach, so supporting the electrification of fleets. Obviously, fleets are fairly significant contributors to air quality, and certainly in London and other urban areas. So we've committed to something you can see in the top right of the slide called EV100 with the Climate Group, which is a commitment to convert our entire fleet by 2030. So we committed to this with a number of other very significant fleets within the UK before the announcement of the ICE vehicle ban on sale of new vehicles. And I think that has helped to drive that agenda forwards and show that it is possible and we are committed. And then green energy is supplied to all of our charging solutions through our business energy team, and I think that's really important that you understand and account for your kind of ESG scope 1, 2 and 3 emissions. So there's not just damage done by vehicles and air quality on the road. The whole supply chain needs to be green and needs to work together. And no doubt the activities by EV100 and various other parties to clean up their vehicles and their energy supply will have helped to improve air quality already, I would hope. And we continue to lobby with local and national policymakers to accelerate net zero. So we're engaged with BEIS, OZEV, DFT, TfL, all the names that you'll be aware of, Energy UK and Ofgem, and we continue to push for that. And there is imminently expected national EV infrastructure strategy that will hopefully help to drive some of those changes that we need to see in the market. I think I'm still all right for time. I've only got a few more slides, Helen. Do shout if you need to hurry me up. One key focus area that I wanted to cover quite quickly is buses. Obviously, buses in London and in Camden are everywhere. Importantly, we need to use them more, so please do use the bus. It's been a difficult couple of years for the bus industry. There's 2 projects I'd like to highlight to show the kind of scale of change that's already happening and has been happening for the last decade or so. So the first one is the Waterloo bus depot with Go Ahead. So it was the first fully electric bus depot in Europe. There was charging infrastructure installed in 2016, 47 fully electric buses. The project actually started in 2013, which hopefully gives people a good view that we're well into this journey now. We do understand it and we're getting it done. And that 47 bus infrastructure is estimated to save around 700 tons of CO2 per annum, which is quite a big number and quite a good thing to be able to say we've been involved in. The bus to grid project is the second one. So I know Louis touched on bus to grid or V2G. lightly. So V to G is basically the same for bus to grid, it's just buses, not vehicles. And that project started in July 2018 and again was funded by BEIS and OZEV, led by Innovate UK. And in theory, we're not quite there yet, but we almost are. We'll allow 28 double-decker buses to discharge up to 1 megawatt of power back to the grid, which might not sound like directly linked with air quality, but it is, because in terms of the grid connections, the more availability there is on the network, the more chargers and the more energy solutions can be implemented, and the quicker that kind of green revolution can happen. So these buses do store quite a significant amount of energy. They can complete their daily routes and come back into the depot. They can charge and they can then sit as an asset to support the grid when there are times that it needs that support. And again, enable potentially other areas locally to connect assets they wouldn't otherwise be able to connect to the grid at that period of time. It's not a commercially viable proposition yet. We are still proving that use case, but it's really important to keep these sort of projects moving forward so we can understand at which point we can convert it to that. And I think there might have been some references to flexibility markets, but those flexibility markets will undoubtedly grow over the next 10 years and will drive significant value, and that value can then be used to increase the electrification process of vehicles. Next point for us is EV charging hubs. So we have a specific ambition at SSE to deploy hundreds of EV ultra-rapid charging hubs across the UK and Ireland, which obviously have a direct impact to air quality in the area that they're deployed, because theoretically all the vehicles in that area will then be able to convert to zero emissions. And I will park the tyre particulates conversation because I can't solve that as well, but at least tailpipe emissions can be dramatically reduced. And we have a specific focus on sharing those locations. So I've deliberately called them community and fleet charging for all, because there are different times of the day that different fleets operate and the community users need to use those chargers. So I think it's really important to understand that to date, the majority of EV installations on home charging have been on people that have off-road parking and driveways, and those fleets that have space in depots and out of town locations. Actually, in reality, people living in flats like the building you can see on the right here, and fleets that come into and out of London on a daily basis need that charging provision. And the best way to get value from land and space in London and grid connections, which are challenging, is to make sure that they're effectively shared. So we will address that with time of use, pricing in the longer term, but also from the shared use of the bays for different purposes during the day. It's not quite common in the market yet. Charging tends to either be public or private, and I think we'll see that change over the next 5 years or so. The last point I'd like to make is just around access to land, and if anyone has any sites in Camden and Camden area specifically that they are looking to electrify and they need any help, then this is an offer of support. We are always interested in having that conversation, be it from a wider energy solutions perspective or the EV charging perspective. And if I can't help, then I'm more than happy for someone to contact me. We all have quite a good networks in the EV sector and beyond, and I think the kind of green collar sector is very positive and progressive. So together, if we speak to each other and pass those connections through, we can drive that positive change, and we need that across our communities and our workplaces. It's probably time for me. I'll stop there.
Great, thank you very much, Simon. So we are now into the questions. So please be adding your questions to the Q&A. You can add them as we're going along. So I wanted to start with a question for both of you on electrification, because this is something that I think there's kind of mixed messages here a little bit, and it's a complicated topic. It's always going to be that way. So I'm a lifelong cyclist. I cycle everywhere. I am leasing an EV at the moment, and what I've really noticed is that everyone talks about home charging, but actually, if you're able to home charge, I think you should probably be on your bike. And if you're going a very long way, you should probably be on a train. And so it's these middle journeys where you do need rapid chargers, where actually I think you do need chargers. And I was just wondering what you're both seeing when it comes to electric vehicles and the types of journeys that we make in the future, because all of this infrastructure now is predicated on people using cars as they use them now. But if people are
cycling and walking more for short journeys and maybe using micromobility, scooters, that kind of thing, then you don't need so much small scale local charging. You need it for those middle distance things. And I was wondering what you both thought about the way that people will use vehicles in the future and who will use them. Who wants to take that first?
I can put a little bit of color into the sort of why home charging. I think it's a really good point that we should be using bikes as much as we can. They're great technology, but there's still a lot of journeys and a lot of people they don't serve as a need. So if you're going anywhere with kids, if you want to do a lot of shopping, there's arguments around sort of mobility, and there's considerations around the distances that a lot of people are going. It's very good for really close things, but not everyone lives where they work or within a reasonable distance to cycle. And for those people, it is important that they need to be able to charge conveniently, and it's not going to convert people who have a vehicle and use it and like it and have it in their lives. It's not telling them to use a bike is not. So we need to make that journey as easy as possible.
Simon, have you got anything to add to what we're planning for the types of journeys that people will make?
Yeah, so I work quite closely with fleets, and they have to plan very carefully exactly what types of journeys they complete and what they're carrying and what the ranges are. So I'm not necessarily seeing a change in the vehicles. It's more a change in the way they use those vehicles. And I think that in itself is probably a benefit, because previously it was very easy to put 400 miles of diesel into a vehicle and worry about it for a week or two, but actually we're seeing fleets and businesses starting to go, right, actually what's the use case for this vehicle, what's its range, and what are the alternatives? So there's a lot of commercial activity around the kind of e-cargo bike sector and last mile delivery. I think we'll continue to see I would call it an improvement. Hopefully we'll continue to see an improvement in the use of those alternative options. I mean, with buses and larger vans, there probably for a while going to be some direct alternatives, but it's about maximising that opportunity. And I think it probably comes back almost to that shared access and shared usage again. If there's vehicles at depots that can be used over 24 hours rather than for 2 hours and then parked for 22, that's also something that we're seeing people look at more, because EVs are slightly more expensive as assets. You don't want to buy something very expensive and just sit it in the corner of a car park and barely use it. So there's a kind of utilization question as well.
I was just going to say, well, I'm certainly seeing a lot more cargo bikes around actually, which surprised me. It surprises me how many I see in London. But go on, Louis.
Oh yes, so I was just going to say, I was just going to add Brittany to my home charging point. Just having one home charger installed in a good location, it can mean a lot more than just facilitating the charge of one vehicle, for example. So cars are idle for 90-95% of the time that they're there. So community and community charging solutions or driveway sharing solutions are a really important way that we can increase the accessibility of these electric vehicles, and do that through people's own homes and own driveways, and incentivize it that way as well.
Okay, well, we'll take so John here in the questions has asked quite a lot. So John, if you could come online, but perhaps condense all of your questions about types of charger into one or possibly two questions. So whenever you're unmuted, off you go.
No problem at all. So I've been doing this for quite a while. I see on lots of presentations from EV charging companies this talk of 22 kilowatt AC in the UK, and we seem to be quite unique in the UK in pushing this. And I think the market doesn't understand it's not the rating of the charging point that determines how fast a vehicle will charge. It is the onboard charger or the battery management system. So a 22 kilowatt charger doesn't charge a car 3 times faster than a 7. And I just wondered, what are Louis and Simon, what's your opinion on the 22 kilowatt and why is it being so prolific in the UK? And I've never seen it in another geography. And I've worked in Norway, Germany, the US.
And perhaps before you answer that question, one of you can deal very briefly with the AC/DC thing, because I think for people who don't use electric vehicles, that distinction in this context is not always clear. So could one of you deal with that and then move on to John's question?
Yeah, I'm happy to jump into that, and I'll have a first run at the question for John. So thanks for the question, John. So AC charging is basically slower charging. So it comes off a standard panel inside a house or a building, and it's not as fast as DC. I'm trying to do it in a kind of sensible way that everyone should understand. It's not as fast as DC charging because it's taking a standard AC current, whereas DC charging is direct current. And that just basically thumps power into the vehicle as fast as it possibly can. AC is far more limited in how much power it can transfer, and DC charging is far less limited. However, there are other factors for DC charging, like cooling of cables and cooling and management of the battery packs. So you tend to find that AC charging is used for longer dwell time and slower charging, whereas DC charging is rapid and ultra rapid charging for people on the go. So you're kind of talking homes and offices versus motorways and forecourts, fuel stations, if that helps.
So on to this issue then of the 22 kilowatt AC.
Right.
Yes.
Go on.
Yeah. Yeah. So I can enlighten this a little bit. So the kilowatt is sort of like a measure of the power that is supplied to the charger. The reason why a 22 kilowatt charger shouldn't charge 3 times as fast, wouldn't charge 3 times as faster as a 7 kilowatt charger generally, is to do with the power supply to the charger itself. So most homes, most like domestic places that you'll have an EV charger installed at the moment, in the UK they're rated to like 7 kilowatt. You need so that's a single phase, and that's what most homes have. Germany, for example, has 3-phase as standard to each home. So you'll have a 22 kilowatt charger. In the UK, it would only be supplied with the 7 kilowatt that you have to the house or that you can supply to it. In Germany, it would use the full 22 kilowatt to charge the car because they have 3-phase supply to each house. We know that the grid infrastructure is going to have to be improved in the UK with increased electrification, increased power usage at people's homes. That'll be that's the reason why 22 kilowatt chargers don't always charge as fast as they are capable of doing. The business is a slightly different case, but it's to do with scaling up or improving the UK domestic electricity infrastructure.
I want to come off that. Oh, go on. Very briefly, John.
Very briefly.
Sorry,
just going to make a point on that. It always comes down to the use case. So a lot of people take the attitude, and I think it's kind of a human nature thing, that I want the biggest or the fastest, and 22 AC tends to be the best you can get on a 3-phase connection in a building. And I've spoken to lots of fleet managers, and they say, I just want 22 kilowatt. And then you go and start digging underneath that and say, why? What vehicles have you got? Can they charge past 11 kilowatts? So, yeah, I think there has been a bit of a prevalence, but a bit like lots of people drive around in, big SUVs when they don't need to, and they could cycle. It's a human nature and a behaviour that we will hopefully change over time.
Well, I think it's difficult in this case, not to defend that decision specifically, but people are also trying to future-proof. If you're getting ahead of the game, part of the benefit is meant to be you do it once and then you don't have to do it again in 3 years' time. So if all the numbers are getting bigger, you can see the incentive to pick a bigger number because, that's the way it's going. Yeah. But I wanted to ask both of you, because really, just look at how quickly this has happened, right? Is that even in this discussion, as soon as we get to charging, there's a lot of numbers. Charging is complicated. And one of the things anyone who drives an EV is faced with is that there's a very steep learning curve of which types of plug go in which sockets and which things you can plug into and and it is a mess basically. And so my question is, how do we, at what point does this just become simple, and why should anyone who can't afford a very expensive EV, because they are expensive, why should anyone in that position care about all these numbers? Right? Is this just a niche interest for people who are lucky enough to be in this position? How do we make it simpler anyway, and why should everyone else care? 3 questions in one. There you go.
I'm happy to go again if you want me to on that. I think on the charging plug situation, we've been through type I won't get too technical, type 1 and type 2, and then CHAdeMO and CCS. They're all different plug sockets for anyone that doesn't know. And what we've seen over the last few years is a prevalence towards what we call a CCS combined charging system, or CCS2. And what that actually does is it aligns the type 2, so the AC and the DC charging, into a single port on the car. So I think the market has moved from what was very, very advanced technology through to a kind of normalization process. I expect we'll stop calling it type 2 and CCS, and it will just be called the plug on your car soon enough. Not to play down the use of CHAdeMO and other functions, but I think it's about understanding and learning. I remember the first time I went to go and put petrol in my car many years ago, and even that at the time you think, blimey, what, do I just lift it off? Do I need to do anything? So I think it will be generationally improved, and there's all sorts of campaigns and kids and schools groups that show that, which I think is really important. I'll stop now. Sorry, I'll let Louis get him.
Go on.
No, it's really great. I'm just going to do two really quick points. So electric vehicles are a bit more expensive than ICE vehicles at the moment. Two reasons: they're a new technology, they cost a lot to scale up and to start producing and everything, and also but that cost is going to come down. The main thing which doesn't exist for electric vehicles at the moment is a second-hand market. So the biggest purchasers of first-hand vehicles are rental companies, right? Rental companies stopped purchasing vehicles during COVID because people weren't using them. That sort of stoppage on the second-hand car market, I think we read a lot about it like about a year ago or so, but it's still there. That stoppage has essentially left the second-hand car market non-existent, and that's impacted EVs at a time when they're going to be coming in more affordable. So they sit like the prices are going to come down as the second-hand market proliferates. That's going to serve anyone that can't afford a new vehicle, including myself. The second point is that even if you don't own an electric vehicle, and an electric vehicle doesn't seem like an accessible technology to have right now for you personally, and I'll put myself in that bucket, it is one of the key technologies to decarbonising transportation for anyone that does have a car. About half of the people in the UK at the moment have access to a personal vehicle for their own driving. To replace all of those internal combustion engine vehicles, we need electric vehicles, and those emissions affect everyone, not just the drivers of those cars. So promoting electric vehicle usage and the infrastructure that supports it is one of the most important things that we can do to promote decarbonisation, to promote clean air, and that's why we should care about it even if we don't own one personally, because it affects us.
And I was just wondering about the bottlenecks to all of this, because, we can see you showed, one of you showed data on the speed at which electric vehicle uptake is going up. I think there's data that says at the moment, electric cars on the roads are increasing faster than rapid chargers are increasing. Like there is suddenly a whoosh, and the infrastructure isn't quite keeping up. And so I was wondering, like, what are the bottlenecks to all of this happening even more quickly? What's slowing it down at the moment?
Oh, that's a good question. That could be a very divisive one. I think there's a couple of challenges. One is around planning and planning regulations, and it's a perpetual conversation with anyone that's trying to deploy large scale EV DC charging. So for the right reasons, planning regulations exist and make sure that we don't do silly things in the wrong places. However, the planning system in the UK is not the most speedy, is probably the diplomatic way to put it. So it's a challenge when you get a site to get it from concept and kind of early development through to actually deliver. I think I'll try and avoid using the EU related B word, but there have been some challenges with equipment and supply chains, which will have affected some, and obviously the pandemic, which we mentioned. I think also there is still yet to be full clarity in all spheres on the government strategy. We said we're waiting for the strategy paper to be released shortly. There's a lot of collaboration between all the businesses, I would say, involved in that. But clarification on that would be greatly appreciated, and I think we're certainly as a business within SSE trying to help accelerate that as a kind of whole systems approach, so we understand where technology needs to go in today to future-proof that for the future.
I'd only add to that from the manufacturer's perspective. It's making the devices to keep up with demand. The demand is huge. I'm gonna blame the global supply chain issues on why the rollout of the infrastructure has not been keeping up with the cars. Quite at this point, the car manufacturers, they all have exceptional relationship with the chip manufacturers. They've got loads of deals, and their supply chains are very, very well protected. A lot of the infrastructure that goes into supporting those electric vehicle chargers, so like the stuff that we manufacture, that is just as complicated and snarled a system, and it's something that we have to sort of like innovate our way through. But it's scaling. It's demand for EVs is going to be going up, but I think there's more that the government can do to prioritize it over just the easy energy dividend that you get from internal combustion engines and from using fossil fuels. Like fossil fuels are cheap, they're fairly easy to access. That just needs to not be the case.
Just become a lot harder, haven't they? So we're watching what happens when you give that a kick. So I want to move the conversation on to something else, which is shared vehicles, because, and this relates to the cost actually, because as is pointed out by everybody in this field, most cars spend most of their time just being a sort of pile of metal on the road, not like on the in a garage or in a car park, not moving anywhere. And actually what we want really is to produce fewer cars, so that, because there's a cost in making a car, an environmental cost. And so I was wondering whether, in the sort of thinking about electrification and sort of infrastructure stuff, are there things that we can do now that will make car sharing easier in the future? Because it seems that that's an essential transition.
Yeah, I'm happy to jump in again. So I think car sharing as a concept is quite alien to a lot of people, and the behavior of having your own car and it's your car with your stuff in it is very well ingrained in society. But actually, once you realize that you sit on a different a different seat on the train every day and a different seat in the bus, actually it's not much different if you do that with a car. I know at my last business, I worked at EDF prior to SSE, and we set up a fairly successful pool car scheme, and I know we're doing a similar thing with minibus travel and station travel with SSE. I think it's something it has to be driven by organizations that can do it and that can prove that use case. There's lots of, when you walk around London, there's lots of various car sharing bays, and it tends to be, I would suggest, a younger demographic that have chosen not to buy a car that use those shared cars. So without wanting to sound like I'm an apologist for it, I think that the change over time will be people that don't buy cars tend to use car sharing more, and people that already have cars will be harder to convert and take longer, but may catch up eventually.
Well, it was actually quite sad. So London did have an electric car share scheme called Blue City, I think, that went out of business because it was ahead of its time. Louis, have you got anything to add on the car sharing?
Yeah, so I think that car sharing, I think the financial incentives are already there. There's a lot of successful car companies that in London, Beco, like Zipcar and everything. I think the incentives are there. I think the thing which will accelerate it to a point where it becomes a large enough part of our infrastructure is where the cost of the alternatives, so where the car that is like the ICE vehicle that is manufactured from start to finish, that that has so much environmental, it's got that much steel in it, but then even when you've made it, it will continue to consume fossil vehicles. The closer the cost of that car and operating that car reflects the environmental damage that was caused into making it and running it, the closer that cost gets to reality, then the more naturally these car sharing, and especially car sharing of ultra low emission vehicles or electric vehicles, let's say, the bigger the market forces that will promote that. So this kind of thing can be led by government policy, nationally, internationally. The cost of that ICE vehicle, its manufacture, and its the fossil fuels that go into it needs to reflect the damage that is done by it.
Well, I'm not sure whether a global spike in energy prices connected to geopolitics is the best or the worst time to have that discussion, but I'm sure we're all about to find out. So it is time for this session to come to an end. Thank you very much to both Simon and Louis for their contribution. I told everyone we're going to have a tea break. We're not. We're working hard this afternoon, so we're going straight on to the next session. And this is another pair of talks. And now we're into cities, the past, present and future of cities, specifically talking about two examples, London and Beijing. And we're going to start with London with Stephen Inch from the Greater London Authority to talk to us about the past, present and future of air quality in London. Stephen, over to you.
Hello, and thank you very much for having me here. I'm just sort of padding slightly for time while I get my presentation up, and I think that should, well, that how do we do this in slideshow mode? So there we go. So hopefully you can all see my slides. My name is Stephen Inch. I work in the air quality team in London. I've worked across a number of areas, and most recently on the expansion of the ULEZ, which I'll talk about a little bit as my talk goes along. But first, I thought I'd like to start with a bit of history. And I always quite enjoy doing this at the start because it's nice to remind ourselves that air pollution is not a new problem. So I think the first sort of known policy document for air pollution in London was this Fumifugium in 1661. And quite interestingly, some of the things they were talking about then were around coal and domestic heating and air pollution making people sick, which are all still familiar themes, sadly. By sort of the turn of the 20th century, with a lot of industry in London, it actually got to the point where the light in the air was so different that impressionist artists like Monet were coming to London to paint the incredible skies, which maybe made for beautiful pictures like we see here, but not such beautiful lives. In 1952, we had a big step forward, I think, as the recognition of the role of the Great Smog in sadly killing thousands of Londoners. But this led to the first of the Clean Air Acts, which would be a huge step forwards and sort of proof of concept, really, that legislation and regulations could start to make a difference. And the bottom two pictures here are actually paired together, so they're the same building. In 1952, we had the Southwark Power Station, and today it's repurposed as the rather wonderful Tate Modern. So industrial sources are less significant, I think, in modern London, but there is still a great amount of work to do. And it's always worth reflecting on why we're doing this, why we need to do this work. And the principal reason is obviously that it's the health impact of air pollution. So we still see, in 2019, air pollution contributed to around 4,000 premature deaths in London. And it's not just about dying young as well. There's living with some of these conditions like asthma and as somebody said to me recently, that if you grow up as a child in London with the current levels of air pollution, your lungs will be smaller by about the size of two large eggs, which these are lifelong impacts. And all children already go to school in areas exceeding the newly revised PM 2.5 guidelines. We saw during the COVID or the earlier stages of COVID that air pollution interacts with infectious diseases as well. Lung and chest diseases can be exacerbated by air pollution. And there's also a huge inequalities aspect to this. And I think in broad terms, the air pollution tends to be worse where people are less well off. So if you live in the more deprived areas of London and you already have a lot of life challenges, you're also experiencing the worst pollution. So these are all really good reasons why we should be thinking about taking on air pollution. And the current mayor has made it a priority, which I think is a great thing. what that means in practice is that it's not something that's just done as a little standalone thing. Actually, thinking about air pollution runs right through all of these core mayoral strategies, from the environment strategy to the health and inequality strategy, the transport strategy, the London plan, and actually all of these things need to work together. So, for instance, if you if you want to increase electric vehicle uptake, you need to have the infrastructure there to power those vehicles, and in order to do that, you need to have policies in the London plan which tells you what where you build new things, that we support those as kinds of development. And the overall ambition is for London to have the best air quality of any global city, which is a huge challenge, I think, for a city of this size, and one we hope to be competing with other cities on. So looking back, I mean, I think it's worth saying that we have done well in improving air pollution in London over the last 5 or 6 years. From over 2 million Londoners living in areas exceeding legal limits to a 90% reduction in the size of those areas. We used to get our first sort of exceedances of the hourly NO2 target on the 4th or 5th of January each year when I started working at the GLA, and now it's only a handful each year. And we're on track for legal compliance by 2025, and we're actually, I think, a really good comparator is that we're progressing in London at about 5 times faster than the national average. So how do we do it? I'll start with some of the big initiatives. So low emission zones, it's not well known that London actually has 2 low emission zones, one for large and heavy vehicles, so HGVs and bigger vans and some of those inherently more polluting vehicles, and that covers the dark green area there, so nearly all of London. That's been around since 2008. Then there was a big step forward in 2016 when in the central London we started charging all vehicles, so including vehicles owned by just ordinary people. We tightened those standards up in April 2019 and called it the ULEZ. Then in March 2021 we tightened up the standards of the low emission zone so they match the ULEZ standards, and then we expanded the ULEZ in October last year, although there was no change in standards, but that now covers that sort of medium green area that you can see there. Probably worth, hopefully most of you know this if you're Londoners, but worth rehearsing how the LEZ and the ULEZ work. They're effectively their incentive schemes. So we don't have the power to ban specific types of vehicle. And instead, what we do is we use charging structures to kind of incentivize people to change. For an ordinary car, that's £12.50 a day if you don't meet the standards, and that's sort of enough money that if you're a regular driver in London, then you would it becomes sensible to either change your vehicle or ideally change how you travel. Higher charges obviously for larger vehicles because we're looking at businesses who are likely to pay those costs. If you've got a non-compliant vehicle and you don't pay the charge, you get a fine through the post in the same way you would for a parking fine or whatever. There are some exemptions, but these are very, very limited. So they're really for a small number of vehicles that just can't be adapted and perform very specific purposes. There's also a few extended time limits for things like charity minibuses where there'd be unfair impacts if we push those too hard. Because this is an emissions reduction scheme, we don't say you absolutely have to replace your vehicle. We do allow what's called retrofitting, where you fix pollution abatement equipment to your vehicle, and that's only allowed if it meets certain standards and is tested and shown to meet those standards. Generally, that's more of a thing for the large and heavy vehicles, and it's something we've used extensively on older buses. So that's kind of how they work. Oh, we use cameras obviously to detect people as they're driving around. Oh, my slides seem to stop. There we go. So really important question, does it work? And the simple answer is yes. And I think, I mean, you can read the stats on the right hand side of your screens there, but it's worth just explaining what this graph is showing. And the two lines to look at are the green line, which shows how NO2 would have changed if we hadn't had this incentive scheme, if we hadn't tried to make people change their vehicles, just with the natural turnover of vehicles as people buy new cars. That's roughly what the green line is showing, and the red line is showing what actually happened between sort of 2017 and 2020. And I think it's fair to say that's a really dramatic difference. And we're looking at, you know, central London pollution, which was some of the worst, starting to become sort of equal to what we're seeing in inner and even in outer London. And long may it continue. And I think the one bullet point I will read out is that when we expanded the zone, compliance initially was quite high. I think people had taken steps in advance to change their vehicles, but we're seeing consistently over 90% of the vehicles driving in the whole of that large zone are already compliant with the standards, which is a great sign that the expansion will work in the same way as the central zone in reducing air pollution, but albeit in a wider area. It wasn't easy. It was a huge challenge. I always like to put this slide up just to sort of, you know, give you a feel of how much work goes on to make these things happen. We installed 750 new cameras, 1,300 signs, new computer systems. There's over 3.8 million households within the zone now. Not all of them own a car, but we don't know which ones do and which ones don't. So we had an enormous communications campaign to reach all of those people and make sure they were aware. And obviously, you know, doing something on this scale can be unpopular. We got challenges about, is the zone too big? And challenges, is the zone too small? Should we have delayed the zone because of the pandemic? And I think on that last one, I think the compliance rate really speaks to it being the right choice not to delay and not to put things off further. And of course, you know, if you delay these schemes, you delay the health benefits. But that's not the only really big thing we do. We obviously have quite a lot of control over the bus and the taxi fleet. All the taxis black cabs are privately owned. They are licensed by TfL, so we use our licensing to reduce the age limit, to get the oldest, most polluting taxis off the roads, and set standards that say they have to be at least Euro 6 petrol hybrids as new taxis come in. And there are over 4,000 of these significantly cleaner taxis now on London streets, and that's an ever-growing number. Similarly with the buses, actually we have a little more control over the buses. And as we started to see the Euro 6 buses come in, sort of the latest, cleanest models, initially we prioritized those to the areas with the worst pollution, although that's become a bit redundant now because the whole fleet is Euro 6 or Euro 6 hybrid, or increasingly electric or hydrogen buses. So we've got over 500 out of a fleet of about 3,000 are zero emission now, and we've committed that there'll be no new diesel buses in London. All new buses coming in will be hydrogen or diesel. So that's kind of like the really big ticket items. I think some of the other things we're doing, which are perhaps often less celebrated, we work with the construction sector, and this is we have a scheme that's similar in intent to the ULEZ. So for diggers and generators and all those machines on construction sites, we use planning conditions to set a minimum engine standard, and these are called stages rather than Euro classes. But essentially, it's the same idea. The higher the number, the cleaner the machine. Stage 5 is the tightest standard, and we aim to be everything being stage 5 by 2030 and zero emission by 2040. Again, we allow retrofit to allow those older machines to stay in service. And this, I think, worth noting that this is more or less a unique scheme worldwide. And it has proved to be very successful in London. We get quite high compliance rates with the scheme. and we support local action. Obviously, you know, there's the 33 borough councils in London, and we use our funding and some of our advice to help deliver local action at specific hotspots or areas that could do with improvement. So we have our these 21 low emission neighbourhoods where there's lots of pedestrian and cycle friendly streetscapes, incentives for cleaner vehicles, installing EV infrastructure, or working with local businesses. Really good sort of ground up stuff to help people change to less polluting lifestyles. We do some things across all of London, like anti-idling campaigns and enforcing the non-road mobile machinery construction stuff I was just talking about, and then lots and lots of other projects that we would, you know, we would struggle to deliver without the boroughs. So things like freight consolidation centres for zero emission last mile delivery, cleaning up canal boats, which are an issue in some parts of London, helping businesses, working with schools to create school streets, and lots and lots of those kind of local projects. We also try and support local boroughs and community groups with monitoring to help people understand the air quality in their area. So there's the Breathe London project's really cool. It uses low-cost sensors, and community groups and local groups can bid in to have a sensor put in their area, or if they've got money, they can just outright pay for one. We fund some, we're happy for other people to fund others, and all of this data gets collected centrally and is there really to give people an idea of exactly what's going on in their area. And part of the point of this is to help people lobby for more action in their area if they feel it's polluted. And that's all easily accessible online, and it's a really great resource. We acknowledge that, you know, we haven't finished the job of cleaning up the air in London, so we do alerts when air pollution is particularly bad, and there are daily forecasts as well, which come up on our website. If it's on the day before high or very high air pollution, we put out information on road signs, river piers. You may have seen them on bus stop signs and all of the underground stations, and this is to try and try and inform people who are at risk from short-term air pollution, but also to try and persuade people who are creating pollution to change their behavior and help manage that for the day. Moderate alerts, we send these out on social media and our website, and again, that's really to help people who are vulnerable to air pollution. And happily, those are going down in number as we go along. So building for the future, I think. So that's kind of a summary overview of what we're doing now. As we look into the future, we know the job isn't done. So one area we're looking at is spatial planning. So we know the population in London is still continuing to grow, and the London plan looks to manage that through this concept of good growth. So rather than just ramming lots and lots of people in, it's growth that's socially and economically inclusive and environmentally sustainable. And for air pollution, this really means making sure that new developments that come along are thinking about air pollution at the design stage, to make sure that the buildings work and they're not just, you know, car-led developments. They're integrated properly with cycle lanes and walking infrastructure and public transport, that they're heated in a way that produces no emissions. And it also, you know, that's how we created this non-road mobile machinery zone, and we have like these minimum standards of things like air quality neutral and air quality positive for the larger developments. We've also done something quite challenging in saying that legal limits aren't where we're aiming through the London plan, that actually the WHO targets have the same weight in planning decisions as legal limits. Electric charging, I think I mentioned before. If you want people to drive zero emission vehicles, they have to be able to charge them up, and the majority of Londoners don't have off-street parking, so they can't charge at home. So we've invested heavily in introducing and supporting electric vehicle charging throughout London, and about 30% of the charge points in the UK are actually in London, and we see this reflected in a higher uptake of electric vehicles here, and we're continually sort of revising these strategies to try and deliver more and more of these to get that change that we want to see. But we know there's more to do. I think one big challenge last year was the WHO, the World Health Organization, revised their recommended guidelines a long way down. They halved them for PM 2.5 and they quartered them for NO2, and this is a huge challenge for us. One of the things we're doing is the Mayor's announced he'll consult on a further expansion of the ULEZ to London wide to happen next year as a stepping stone towards smarter pay by the mile road user charging. And none of the cities really looking at doing that, but this is the idea behind that, is to try and actually reflect the environmental cost of driving in the way you pay to access the roads. And obviously we try and support people through scrappage schemes for that. And then also we're looking at, are there any remaining air quality hotspots by 2025? Do we need to take local action on those? And we're also, revising some of our strategic guidance in the or strategic analysis in the light of the new WHO targets, and work out how we get there and what steps we need to take and how much we need to lobby government to help and assist us with meeting those targets. So I think that's the end of my slides, and hopefully that's about right on time.
Yeah, very, very disciplined on time. Very good. Thank you very much. Well, so I've got to say to the audience, so this session will work the same as the others, which is that you will be able to ask Stephen your questions, but we'll ask you to wait until after our final talk. So hang on for 20 minutes. However, you can be putting your questions in the Q&A tab now and all the way through the next talk while they occur to you. But just before we get to that, we have our final talk for today. And one of the great things I think in this area that I see actually more and more in the general transition, energy and transport transition we're going through, is cities, specifically local areas, learning from each other. And so we've got a great example of that now, because we just heard about London, and now we are going to hear about Beijing from Professor Zongbo from Birmingham University, who will give us a similar past, present and future on air quality in Beijing. So Professor Xi, the floor is yours.
Thank you very much, Helen. Thank you for inviting me to give this presentation here. So as you see, I'm from the University of Birmingham. Can you hear me okay? So before I start with my talk, I'd like to acknowledge the funding from the UKI, from Natural Environmental Research Council, Medical Research Council, and the Chinese Science Foundation. So there's a lot of those comes from the major research program funded by this jointly funded by UK and China, and with like over 30 institutions in UK and China. So my talk will be hopefully relatively straightforward, a very brief introduction, and I'll talk a little bit about the haze problems we had, and look at the trends in air pollution in Beijing, and what did they have done to try to clean up the air, and looking a little bit further ahead about the net zero policies and how that might affect air quality, and then finally what lessons we have learned from the past experience in Beijing. Well, before I start, I think probably have a quick look. Someone might have introduced this before. The key pollutants that we're worried about is PM 2.5, ozone and nitrogen dioxide. PM 2.5 is the particles that are less than 2.5 micrometers. And if you look at your, the diameter of your hair is roughly about 50 micrometers. So it's about 20 times smaller than the diameter of your hair. So it's really, really small. And usually the particles that can enter into our body is something we call like a PM10. And those PM 2.5 are the particles that can enter into our lungs, causing the real damage. Now I made a rough estimate about how many particles we have, we breathe in every single day. On average, urban background areas, probably somewhere where most people are living, we're looking at 50 billion particles we breathe in into our lands every day. Not all of them will be deposited and causing damage. Let's say 10%, but even 10%, we're talking about 5 billion particles we have to get rid of every single day. And if you're living somewhere close to roadside, you're talking about 3 times more of those particles. And we're talking about 150 billion particles every single day that we breathe in. So the particles is the thing that you could easily, hopefully understand that once you get into your body, it starts to damage us. Now, let's look at the haze problems. The past a few years, particularly before 2017, that you probably remember a lot of those news about the heavy haze pollution in China, and this is the BBC News, where in that particular case, so if we look at this visibility here, the visibility is this one. It can go down to less than 100 meters. It's pretty horrible. But if you look at the actual concentration, it could go above 500 microgram per cubic meter. Now, the WHO new guidelines means that the annual average should not be more than 5 microgram per cubic meter. That is 100 times higher. And sometimes the maximum, the number, or air quality index, is 500. So the report, the actual measurement goes above that maximum air quality index, means how bad that is. There's another typical photo taken about this. It's a television center. China is struggling, and it is still struggling, but it's getting better. This figure shows the pollution levels, pollution level changes. This top one, for example, here is the PM10. Remember that PM10 is the particles that can enter into our body, but not all of them. It's only in the PM2.5 that would enter into our lungs. So over the 20-year period, we're seeing a significant change or reduction in the air pollution levels. Particularly if you look at the sulfur dioxide in this cases, we're really looking at a huge improvement in air quality from Beijing. Well, one thing that I remember that is, if you look at what London has done, did from 1950s to 1970s, over that 20-year period, the air pollution level has dropped by nearly 80%. So we're trying to say, okay, Beijing has done extraordinarily well. Over 20 years, the pollution levels has been reduced so much. That's kind of becomes our global example of how air pollution should have been managed. But actually, London has achieved more in the 1950s and 1970s. So the pollution level reduced by nearly, the particle concentration have dropped by nearly 80% of that 20-year period. Now, this one actually shows about the PM2.5 levels from 2013 to 2020, and we can see that in 2013, it's nearly 90 microgram per cubic meter. But by 2021, for the first time in history, Beijing has achieved its national standard, which is 35 microgram per cubic meter. So that's a major milestone. Now, but we should not forget that WHO new guidelines that used to be before 29, as Stefan has just mentioned earlier. Before 2019, the old guidelines would be 10 microgram per cubic meter, and the new guidelines now becomes 5 microgram per cubic meter per year. So we're still really a long way to go to get to the new air quality guidelines. Now, one of the things to look at those yearly changes is that the to evaluate whether the clean air actions is actually working or not is the weather impact. As we might understand that the air pollution level has been fluctuating on a daily basis from extremely low levels to extremely clean to very, very, very polluted. In those cases, could be from like 5 micrograms per cubic meter to 500. Variation. A lot of this variation is caused by meteorological conditions, like if you have a strong wind on that particular day, or the pollution is being blown away. So when we are evaluating something, whether the our policy is working or not, we first have to try to get rid of the stripe after the weather effects. This is what we have done. We have developed new methodologies based on machine learning to stripe out the weather effects, so we can see the real changes if some policy is being implemented in for example, or a lateral intervention such as the COVID lockdown. So after we have done that, this is the real trend that we get from the air pollution levels. So we can see from the 2013 to 2017, over the 5-year period, this is how the PM 2.5 has been changing. The SO2 has been reduced hugely. The nitrogen dioxide has been reducing, but we can see that's a general trend in the ozone pollution going up. I'll talk a little bit further about that later on as a problem that Beijing is facing. Can't move my, oh, here you go. So what actions Beijing has taken in the last like 10 years or so, or 20 years. So one of the major things, I guess it's probably quite similar to what London has done in the 1950s, 1970s, is the energy transition. So from 2013, Beijing government has introduced this clean air actions or air pollution control plan. And over that period, the coal use has been hugely reduced, while the natural gas use has increased. And that directly translated to reduced emissions. But over the more recent years, after 2017, it starts to develop new policies like local zones. So essentially over the whole Beijing and some of the surrounding cities, they ban the use of coal, and that brings a huge benefit to air quality. Now, we are, again, using a quite sophisticated methodology, which I don't want to give details here, is to look at the winter heating. So in the UK, of course, we have winter heating as well in here, but in Beijing, the winter heating becomes a much bigger problem, because it's much colder in Beijing. The population is high as well. Now, don't worry, but so this is what we are seeing here is, let's see, this is the PM 2.5. This is the cities cities around Beijing that could potentially affect air pollution in Beijing. Those are what we call 2+26 cities. And in those cities, there are more strict air pollution control measures, and you can see the contribution of winter heating drops from about 15 microgram per cubic meter to about 8 microgram per cubic meter. So substantial improvement in those 2+26 cities. But if you look at those areas in the other northern cities where you also have the winter heating, but it's not in those cities near Beijing, and you can see there isn't as much drop. They do have a clean air plan, but the plan is not as strict as in those 2+26 cities, and you can see that effect is not as big as it is we can see from Beijing. So the other measure, the key measure, is to control the road traffic emissions. So they introduced the new standards. There is no specific like a low emission zone or ultra low emission zones like in London. What they normally do is they would ban completely, phase out some of those old vehicles completely. So they just be banned, not allowed to get on the road anymore. So this is like I guess something that is really hard to do in London, but it could be done, I guess, in Chinese context. But I think the most important thing is to encourage, or not only encourage, but forbidden the polluting vehicles to go on the road. And I think this is one of the key things that we should be doing. Scrap those old vehicles, replace them, because those are the sources that could contribute. Although the numbers are really small, we're probably talking about 5% of the most polluting vehicles could contribute up to 90% of the total emissions of nitrogen dioxide. But the other thing is the really fast uptake of electric vehicles. This is 45 million electric vehicles that's being in 2020. So that's a relatively big number. So we're talking about 8% of the total vehicles in Beijing now is electric vehicles. That includes not just the smaller passenger cars. We're also talking about those medium and large buses, and those also some of those what we call like relative small vans as well. And the other one is the regional coordination, and that is one of the major efforts that have been taken, and that's really really effective. Now, the reason to do this is for PM2.5 pollution. We look at what you see at a rural background areas. Let's say in London, outside London, we're probably talking about the PM2.5 levels it's about 20% less than that in the city centre. So the urban background or the rural background and urban background is really quite similar. It means a lot of this pollution is regional. It's not from Beijing itself, it's from the surrounding cities or surrounding rural areas. And this is the same thing in London. We're talking about a huge percentage of PM2.5 comes from the regional sources rather than London itself. Now, Beijing is a really peculiar place where it's sitting here, but the upwind areas in the Hebei province is a highly industrialized region where the pollution levels are extremely high. So whatever you do in Beijing, if you don't control those regional sources, you will not succeed. And Beijing has done a lot of work. They have formed the specific units to develop technologies, to develop policies to control pollution from those surrounding regions. Probably not much time, but very briefly about what's going to happen with the net zero. So there is a carbon neutrality or net zero policies in Beijing, in China, and the net zero policies in the UK. And what this modeling study has showed that is this is the current pollution levels. You can have really high levels of PM2.5 in those in these regions here, but assuming our nationally determined contribution emissions with the best available technology, the pollution levels will be reduced hugely, although it's still going to be above the WHO air quality guidelines. And this is another study where they look at those in the longer term, let's say by 2060s. What you might see is under different kind of scenarios, you could see those pollution levels on a average in the whole China, we're talking about 7 microgram per cubic meter, which is again still higher than the WHO guidelines. That is, let's say, that 2060. So we're still a long way to go, but even that, we're still not going to meet that guidelines. But looking in other areas, some of those, let's see in Beijing area and the surrounding regions, it's going to be more than 10. It's just much harder to achieve. The problem with this is that even there is 0 anthropogenic emissions, some of the places in China, and maybe even in many of the other countries, will still be above the WHO guidelines. So it's a challenge for those some of the cities where they have a lot of that lateral sources. So one of the things we are currently working on is to develop a UK-China collaboration to optimize the net zero policy options for air quality and the health. So very briefly, 1 minute, hopefully, some lessons we have learned, hopefully. It's very effective air quality management system. I think London has set up great examples for China and the rest of the world. There are also things that we might learn from the other side as well, from China, for example, including the legislation, standard setting, enforcement planning, particularly regional coordination, something that I think is really important. To the monitoring and public engagement, which London's done extremely well. Always, energy transition is the key. More renewable energies will be essential. Scrap the most polluted vehicles and uptake of electric vehicles, which has been discussed before. And Beijing does have really advanced air quality monitoring systems, and they have developed data science for decision-making processes, and that's something that that London may and other cities may also need to learn from. And there is a global scientific knowledge about air pollution control, not only from the US, from the UK, from Europe, from Japan and China. And so making use of scientific knowledge will really help us to better develop those best knowledges, best solutions or policies. The challenges the Beijing is still facing is really far away from the WHO guidelines. It's improving, but it's still far away from the guidelines. There is also an increase in ozone pollution, which I think some of the Western cities are also facing. We also have a challenge to optimize the net zero policies to improve air quality and health, and regional pollution remains the big challenge, and also the inequality from the rural areas, from the women and children remains a challenge. And that's all from me. Thank you very much.
Thank you very much. So we have some time for discussion with both our previous 2 speakers. Now, so there are not many questions yet. Everyone's got towards the end of the day and wants a cup of tea. But if you have a question, do stick it in the Q&A tab. But I have questions, so we will start with those and we'll pick up on audience questions as they come. So my first question for both of you is that, I mean, it's great to see these 2 big cities, both at least improving air quality. You can argue about how fast things go, but at least it's going in the right direction. But the question I've got is about how the contribution of open data for the public, because it's great that experts like yourselves can sit, you've got PowerPoint presentations, you've got numbers, you can show these graphs. But we heard this morning from Rosamund Kissi-Debrah, and she was saying, well, what she wants to know is, if you walk out on this street, what's the air pollution like today? She's just an ordinary citizen walking around London. How does she find out what this invisible thing is doing all around her? And I was interested both in, what your cities are doing about really bringing this data to the public, but also what contribution is being made by the public putting pressure when they have that data, because obviously if someone can see this is how bad the air pollution is, they're going to go asking questions and wanting things to change. So I wondered if you could both comment from the point of view of those cities on open data and really the most transparent data possible. Perhaps Stephen, you can go first.
Yeah, I think the open data question is a really interesting one. It's a huge challenge. I think, in the world we live in now, where everyone has a powerful smartphone in their pocket, I could probably type in a list of URLs into the chat in this, here that could give you fairly live data. And I mentioned the Breathe London project and things, both for London. You could probably find out Paris, Beijing, New York at the same time. I think the question, this really, I've heard Rosamund speak before, and it really speaks to her question, is actually about interpreting that data. So I can point you at somewhere that will show you a load of monitors that will give you a new number every 7 seconds. Some of us on this call are expert enough to understand what that number means and to interpret it in terms of our daily lives. But actually, I think for the majority of people, that's not necessarily a great approach. And there was a rash of smartphone apps about 3 or 4 years ago that did just that. They just threw numbers at you. And there's a reason they're not still popular, which is because they don't actually help all that much. And I think this is a huge challenge, and one that was laid down actually sadly after the inquest into Ella Adoo-Kissi-Debrah's death, that we need to get better at interpreting this information for people, or giving people the tools to interpret it for themselves in a meaningful way. So I think that's really the challenge. The data's there. It's turning data into communication, I think, is the big thing. On the other part about building back public pressure, I mean, I mentioned where we prioritised buses to some of the worst hotspots in London, what we call the low emission bus zones, because we love a zone in London. But that really began actually with local pressure from community groups in Putney, who've been doing their own monitoring for a number of years, and really put a lot of pressure around Putney High Street, where the primary source of pollution was buses at the time. And that was the first of our low emission bus zones, but it kind of drove us to develop that concept. So I think public pressure is really important. And I mean, some days I get annoyed by all those letters that come in, but actually in the long run, they're really, really helpful. And they do draw attention to things that we might have distributed our buses in a different way, or, all these things do really help. So I'm all for it, but it is difficult.
Open data and transparency, Professor Xi.
Thank you, Helen. So, interestingly, the air pollution in China or in Beijing is quite different. So it's haze, it's PM 2.5, you can see it. And sometimes, in worst cases, you can smell it. I actually, I was there. There were times where I can actually smell it. So it's kind of a different scale of things. If you look at the data, I think before 2013, there isn't much data there. But after 2013, they have, established a range of national air quality stations. On all the data are completely public available, and they have the predictions of air quality, which is again being broadcast as well. So it's like a weather. Now, what is really interesting that I found about this is the people in Beijing has been exposed to the serious haze events where they just say, okay, I can't breathe, I can't smell it. So people become extremely aware of it, and people learn. So if we talk about, fine particles, PM 2.5, you go to the streets in the UK, a lot of people may not understand what they are. If you go to speak to a random person in Beijing, they would know. So it's kind of an interesting thing, because we don't see it, but they see it sometimes, and then when they see it, they start saying, oh, I'm going to worry. So the education or public awareness is much better in that sense. I think if you're talking about the building up the pressure from the general public, I think that huge pollution event happened in 2013 is a watershed moment where the public have really started saying, this is it, we're fed up. And that is the time where the government have actually taken a huge measures to start to clean up. I hope that answers your question.
Yeah, I mean, and it's very sad in a way that it always takes a crisis. That's what we learn, isn't it? We know there are risk registers all over the place, and there's all these risks, but basically no one does anything until there's a crisis. Well, I wanted to ask you both about the cost of this, because I mean, cities, obviously, you know, if you're involved with someone like, you know, the local authority, the GLA, someone like that, you've got a whole load of people knocking on your door wanting you to do things, right? Fix the roads, sort out the rubbish collection, you know, organize the transport, all of these things. And you've got a limited amount of money. And I was wondering about the sort of cost benefit analysis for a city that's dealing with so many priorities. Is this an expensive thing to do? These changes you're talking about, is cost a limitation? Or is this just, there's a huge long to-do list and it's just somewhere on the to-do list? So again, let's have London first. What are the costs of this? Costs of doing better, I guess.
My goodness me. I mean, it's a huge question. I think it depends. In some ways, it depends how you look at it and how long a period you're looking over. So analysis by the Confederation of British Industry in London worked out that between now and 2050, doing what we do in London will save the wider economy and the NHS in the sort of tens of billions of pounds. I haven't got the numbers to my fingertips. And the costs of, you know, introducing the ULEZ and doing what we've done on the buses and supporting the local action and all the other things we've done in London runs to, over time, a few hundreds of millions. If you do the cost benefit analysis that way, it's a no-brainer, you know. And the ULEZ still does pay some of its own operating costs through the charges. So, you know, there's clever things you can do to improve even on that. I think in the kind of government cycle of, you know, 5 to 10 year thinking, it's a lot harder to make the cost benefit analysis. And in a strange way, I think the GLA is quite lucky in being a little bit constrained. So we, you know, the boroughs within London provide the schools and take the bins out and maintain a large quantity of the roads and do all those things that local councils do. And in a sense, it frees us up to prioritise it as the citywide authority. So the cost benefit analysis looks different at different levels of government as well, I think. But you know, if you're able to think in the long term, it's a no-brainer. You know, the cost of ill health is enormous, and the cost of doing things is only large.
It's always the difficult difference between short-term and long-term thinking. And Professor Chi, how about Beijing? How do the costs and the costs of the measures taken, is this an expensive thing to make these improvements in Beijing?
Absolutely, it's a hugely expensive. I think the 2013 to 2017, the Clean Air Plan itself cost something like in the range of 1,700 billion pound, which is probably quite a big number. I think but the benefit, if you calculated the benefit to it, that's much higher than that. Again, as I completely agree with Stefan, this is a longer term benefit. You're not going to see that benefit next year. I think what is interesting in the Chinese government is you're not changing the government every 5 years, so they're looking at the longer term. They don't really care about the short term benefits or not, or they do, but you know the government starts to make that change that. So the central government had put the air pollution control as one of the top priorities. So if you don't have, at one point that becomes the top priority. So if a city or a province hasn't met their target, then the top officials could get into really serious trouble. So that is the kind of things that they really put that to top. I don't really care about the cost. So they say, what have the cost? We have to clean it up. But if you look at the benefit, eventually it's hugely beneficial.
Yeah, it's one of those things where you think someone's going to look back in history and go, why did they not sort that out? How did they let it get that bad? Well, I wanted to ask you about the current policies and whether there was anything being missed, because obviously, you know, you need to fix lots of things to improve air pollution. It sort of reflects on all, you know, you need to talk to your transport department and your health department and your schools departments, and, you know, there's lots of different things. But I was wondering, in these two cities, are the current policies on air pollution enough, or are there other things that perhaps are a bit more imaginative and a bit more creative that might make a difference, that just don't fit into a policy or haven't happened yet? So how well are we doing on the policies? Again, Stephen first.
Well, of course, as a loyal worker here, I should say we're amazing and we're doing everything, and it's all wonderful. But there is a more honest answer, I think, is, and this reflects back on some of the discussion earlier on regional sources of pollution. You know, we do a great deal within London, but particularly for PM 2.5, we see an awful lot of import from other parts of the UK and even from across the Channel in sort of Northern Europe. So some of that collaborative stuff, I think there's a big source which, particularly for PM 2.5, around wood burning, and there's still some burning of solid fuels in a number of places, and I think that's something that's very difficult to tackle at our level, and we don't have sort of powers or processes to do that. And I think, you know, the government needs to help us look at what the shape of the solution for that is. In terms of technology, a big area, and I think this is a worldwide question, is around tire and brake wear. So we know, in a sense, any sources that come from combustion of any kind, we sort of know the answer, which is stop doing that combustion, or at the very least stop doing it in your cities. Tire and brake wear is a different kind of a thing, and I think there has been some progress, but as we tamp down on combustion of all kinds, those will become much more significant sources, and there's a huge challenge. I mean, brakes work by wearing, right? So so there's definitely sort of an R&D challenge there as much as a policy challenge. So I think those are the ones that spring to the top of my head, and I think, you know, there will always be, as you deal with one source, other ones become more prominent, so there will always be more and more to look at.
Yeah, and I think the tire and brake, I mean, it's a particular bee in my bonnet, but I think there are solutions and there are things happening. It's just they're invisible, and regen braking does get rid of a lot of it. Professor Xu, then, in Beijing, are the current policies enough? Are there other things that could be done that aren't in the thinking at the moment?
I think they have got a pretty good idea of what needs to be done. Is what I guess the more I guess the problem for them is what they could consider to be affordable in a short term, without causing a huge problem to the living standards and inequality. So I'll give you an example about the 2017 in the winter. They got out this no coal zone, or this essentially banning the use of coal, but there isn't sufficient gas, and a lot of the people in the rural areas don't have heating, and that is not good for health. So doing things too quickly for them could then causing the inequality problems. So you try to balance this is a challenge. I think overall, the biggest challenge now is to try to control the pollution, the joint pollution. One is the pollution from other places. You can't really do it when you have like a 70%, 80% of the pollution from other cities. So you've got to try to do that. I think more needs to be done from the end. And the other thing is, the locally what can be done. There is limited, but obviously there is still more that could be done. Particularly something we call volatile organic compounds, which is really problematic because they do form particles in the meantime, they do contribute to the formation of ozone, which becomes a little problem in Beijing.
Brilliant, thank you. Well, we have, I was about to finish, but we have got one anonymous attendee asking a question about particulate pollution on the tube. And one of my PhD students did their masters in this, actually, and was generally horrified by the amount of particulate pollution on the tube. So very quickly, Stephen, because we haven't got very much time, particulate pollution on the tube, go.
Yeah, 2 points to make on that. I think one is there's the composition of the particulates is very different, and this is something the government's Committee on the Medical Effects of Air Pollution have been looking into to understand whether the particulates on the tube are as bad for you as the particulates that come out of car exhausts. The basic difference is that actually that a lot of what's in the tube is wear, so it's iron compounds rather than burnt hydrocarbons. But that aside, there is still a need to reduce the particulates on the tube. So TfL have been conducting a number of trials to find out what works best. So, I mean, luckily we have a number of tube lines. So they've been trying out different approaches to cleaning or using glues or, or operational changes to reduce the particulate on the tube. And when they work out which one is the best one, it will start to get rolled out and deployed more widely. I think, one third thing to say on that is, again, I think there's a great deal of international collaboration starting to happen. So I know TfL have been talking to Barcelona and Washington and trying to make contact with other cities that have underground metro systems and similar problems, so they can start to pool knowledge, because it's a really tricky problem. But rest assured, things, when we know the best solution, it will be deployed.
So rumbling along slowly, it stands to that. Well, we have come to the end of that session. So thank you very, very much to Professor Xu from Birmingham and to Stephen from the GLA. So we have come to the end of today's session. It feels like over the course of the day, we've covered an enormous, just within one topic, air quality, we've covered an enormous range of things, indoor and outdoor air pollution, the health effects, and a particular highlight, I guess, and I don't quite feel that highlight is the right word, but a very important voice we heard today was from Rosamund Adoo-Kissi-Debrah, and her very articulate advocacy for more work on this. And then we had, the nitty-gritty of infrastructure and electrification this afternoon. And then I think finishing by comparing two cities is a really important thing to do, because this is a city-wide problem, and beyond that it's a country-wide problem. But local cities can get together and compare, because they are all little petri dishes trying things differently, and they can learn from each other. So it's been a really varied day. I hope that everyone in the audience has learned lots of things, can go away and take things away from this and keep up the advocacy, keep up working on these topics, because this is a collective effort. So I want to say a huge thank you to all the speakers from today. They have all been brilliant. Obviously, huge thanks to the Camden Clean Air Initiative for organising all of it and all the work they're doing. Anyone listening, if you haven't gone to their website, go there, find their podcast, join in with what they're doing. There will be more events in this series. There isn't one to be publicly announced now, but you will be. If you want to hear about it, you can go to Twitter at Camden Clean Air, or just look at the Camden Clean Air Initiative website. And that is it. So you can take all of your food for thought out into this sunny London afternoon and work out what we're all going to do next. So thank you very, very much to everyone, and we'll finish there for today. Thank you.